of any configurations, but it's there just for display purpose. And you're using one capability which is a KV, so that's the interface, and file system, that's the implementation. So one side you have spider lightning, bring in the KV. One side you have Slide, bring in the file system. And so I actually display the business logic that we have. So cding into source. I'll do a cat on our main file. And in here, you can ignore sort of the first lines. That's sort of just generating the code that comes from our interface and generating specific error implementations for our error type. But that aside, the main thing I want us to focus on is that we're opening a key value store, which we called my folder. We're then setting a key on that key value store, which has a key of hello spider lightning, and it says the value of hello spider lightning. And we're then printing that. So, I mean, you can imagine when we run this, if it works, we'll get a nice hello spider lightning. So let's cd back. Now, to build with Rust, you'll say cargo build. And we're going to target wasm32 wazi. And this should take 6 seconds. If anyone knows any 6-second jokes, never mind. It is done in 569. Okay, with that, we now have a WebAssembly module that we can run with Slide. So let's do exactly that. We'll say Slide. We'll pass in our configuration, our Slide file. And then we'll do run. And we'll pass in a Wasm module. When you build with cargo build, that should be located instead of target, wasm32, and we build it in debug. So we should have a spidey.wasm. Hello, spider lightning. All right. So that is how you yourself can get started with spider lightning. And if you want to add new interfaces, we also have, with the CLI, you can do slide add other interfaces, add runtime configs, whatever you want, and have fun with it. But other than that, we also want to show, because that's not cool enough, we want to show how far you can go with Slide and spider lightning. And to show you just that, we've prepared a demo of a chat app, which I will boot up. So we can close this terminal. Now, we developed this using U on the front end. That's a Rust front end framework. So it's all WebAssembly on the front end and on the back end. So let's start that right now. We'll do a make serve. That boots up our front end. Good. We're running. We'll do a make run. This boots up our back end. Good. And this is being backed by Redis. So we'll run Redis server. Cool. So right now, if we go to 127, we get something that looks sort of like a chat app, or will look once I zoom in. All right, so on the bottom, we have what you want to say. That's sort of the input text field that you can say. And on the top, you see that we're logged in as this very user-friendly line of characters. But I mean, a chat app isn't much with only one person. So let's get another user in. And there we go. We have another user. Let's put them side by side. 1 and 2. And now, fingers crossed, when we say hello, we get hello on both sides. And we can say hi. And we get hi. Oh, I should have said that with the other user. Let's say hi with the other user. And there we go. We get it on both sides. And that's entirely powered by Slide. You on the front end, Slide on the back end, which Joe will explain more just about now.
Yeah, we are out of time, but I will quickly mention the architecture that powers the chat app backend. We have 2 microservices. One is the HTTP server that listens to the request of send request and get message request. And we have a dispatcher service that just dispatch the messages to all the users in that group chat. And those 2 services are compiled to WebAssembly with Spider Lightning capabilities and run in Slide. The HTTP server has it's using a message queue capability to send the message to that queue so that dispatcher can get the message from the, pop the message from the queue, and it's also logging the users into a key value store for persistent reasons. And that dispatcher will dispatch the message to the user queues. So each user in a group chat will have their own queue to get the messages. So each GET request come to the HTTP server, you will locate that user-specific user queue to get a message outside of the queue to return to the front end. And believe it or not, those two microservices can be uploaded to a Docker container and run in a Kubernetes. And that Docker container for each service is about 600 kilobytes. So that Docker container only have one slide file and one Wasm module, no operating system on top of it. And that's it. Thank you everyone for listening.
Yeah, thank you so much.
Joe has the mic, so because that little thing is kind of a little flaky. So any questions? Go for it. Screening with questions. I have a question.
Go ahead.
So, Joe, can you repeat the question for the stream? So in the beginning of the slide, you showed a bunch of different implementations, including AWS, Kubernetes, and things like this, and also Azure. Like, do you intend to have a lot of implementation for a lot of things?
We are doing, so the question is, are we going to have multiple implementations for capabilities? And the answer is yes. We want to have different cloud implementations for those capabilities as well as OSS components. And we are doing this per user request.
Yeah, and that's actually part of what we mean with the slide of let's build cool stuff together. You know, Spider Lightning and Slide are built very modularly, so it's very easy to contribute. If you want to contribute a new interface, you just go and you write a WIT file. If you want to contribute a new service implementation, all you need to know is the SDK for that implementation itself, and just implement the WIT interface. So we would love contributions on GitHub. Go ahead.
What Wasm or WASI or component model sort of specification or feature are you most excited about? Like, what will make Slate tags better?
I have one. Do you wanna? Or actually, just revoicing the question. So you're asking what are like WebAssembly component model, WASI things that we're most excited about in the near future? Do you have one? I'm most particularly excited about the world's PR that we're getting in.
Yeah, I'm excited about the word syntax that you can have different profiles, or we call it words, of different capabilities, and you can use them, use different parts of those Lego pieces in your application. You don't have to bundle them together or bundle them with WASI. And another one I'm thinking about is the component model itself is a game changer. It introduces those higher level types that makes writing the capabilities as interfaces possible. So that's the foundation of it.
Yeah, so hopefully in the future you can imagine Spider Lightning itself as sort of like a world, or the key values of Spider Lightning as a world, and very much excited for that. Yeah, please go ahead.
Is WASI and therefore Spider Lightning compatible with Cloud Events Android Native?
Okay, so the question is WASI and Spider Lightning compatible with Cloud Native events?
Cloud Events.
Yeah, Cloud Events.
And Native.
We actually have a events capability, and that events capability, it's pretty similar to the HTTP server. You can listen, so each capabilities like key value or message queue, we want them to have a kind of like a watch function. You can watch for the key change to that key value store, and that will emit a cloud event. And you can write those event handlers in your application to handle those events. So that's part of it.
Yeah, A lot of that work still has to be done. For sure, we've only implemented watch for key value store.
Yes.
So that is also another good point to contribute. All right. Any other questions?
Great. Thanks, guys.
Yeah, thank you so much.
We're here to hear a talk by Aaron Aldrich about networking and, of course, all how to get the bits through and get the bits flowing, which is always the problem, really. So give a big hand to Aaron.
Hey, thanks.
I'm Aaron. So yeah, I had this thought with networking. We've like everything else, we've layered abstractions on abstractions on abstractions, and now you can like light up an app from a GitHub repo on a service somewhere without having any idea how anything gets to it from the internet. And I wanted to dive back into like the grit of how bits flow through the web, because I think understanding like why things are the way they are will help us untangle those moments where you like kind of make a bunch of arbitrary choices and then a year later find it in production. You're like, oh no, this is bad. Like, how do I undo this? So yeah, I'm going to go through all of that. And I wanted to start first a little bit of interaction with a very classic like interview question. I think everyone's probably had this question at some point during some tech interview, maybe not. But what happens when you visit a website? And I'd love, does anyone have like a good answer or a quick answer? Audience participation time. I know, it's like right before lunch. Everyone's trying to.
Surveillance capitalism kicks into high gear.
Right. But you know what they're asking for, right? Like everyone types in, you put a URL in the address bar, and like what's the first thing that happens when it goes in? Everyone will say DNS. But like, why DNS? Why do we even have this thing? Why can't we just go to a name on a website? It's like, well, because eventually all of these bits ultimately come down to the point where there's like some piece of silicon needs to send some amount of impulses over electricity or light to another piece of silicon that has to answer it. And like, if we had to figure out how to turn names into bits all the time, that's not really sustainable. So at some point we have to figure out what those names are. But this doesn't really answer the question if you get back even further. How do you know where the DNS server is? How do we get there? How does all of that work before you even get to DNS and name translation? So I thought this was interesting. Like, I was trying to figure out like how much traffic is on the internet. And this is roughly the amount of internet traffic per second as of whatever internetlivestats.com believes it is, which is a lot of gigabytes. And also, we don't really measure like ones and zeros in bytes. I mean, we do, but like we've aggregated it up so much, this number like looks less impressive. Like 167 terabyte hard drives, that's a conceivable thing to me. But 1.3 quadrillion bits is like in the realm of absurd, right? And like this is like what's actually happening. This many ones and zeros being sent every second across the internet all the time, which is a lot. And most of them seem to get where they're going and then back and give us useful information, which is remarkable. That's not enough contrast on the screen. So this was one of those old like maps of the internet thing to point out like we're not just dealing with like point to point. You're not just sending data along a web of integrated systems that even this I think shows individual connections and doesn't really belie the fact we've got like meshes and multiple redundancies and like all these other interconnections, that those pieces of ones and zeros have to figure out how to get to the other side without getting screwed up and like make sure they're all in the right order. How many people are familiar with like the 7-layer OSI model? Like I think this is pretty common. It's also like not a thing we've really used since TCP existed, because there's a TCP IP model, which really just squashes a bunch of things because it was kind of an arbitrary separation anyway. All the top 3 are largely things that happen in software, and everything below that is stuff that happens in IP protocols. Transport being like the TCP stuff and your sessions there, and then dealing with IP addresses, and then data link or network access is like, how do we start translating this into the physical world of wires and electricity? And like physical largely you don't have any control over if you're dealing with like corporate stuff anyway, but that's, you know, your actual links. So why do we have these? Like why visualize this stuff? And this is all because of how we actually encapsulate data when we send it over the internet. Like we have this chunk of data, but we have to wrap it around an app header so it knows where it's supposed to go once it gets to your computer. That's got to be wrapped around TCP so it knows which port and how to get there and make sure, you know, we're communicating back and forth. That then has to be wrapped around IP so it even knows which system it's supposed to go to remotely, and that has to get wrapped around your, what does it say here, Ethernet header, right? So for your MAC addresses so it knows where locally to even send this. All of this has to keep getting layered on top. And this is why things like jumbo frames and IPv6 are interesting, because it starts reducing the amount of overhead that we have, the more virtualization and layers we put on this, this has to keep getting repeated inside that data space, and you get less and less room to send information every time you send data over the internet. So the fewer abstractions we can have, the faster we can send data. Or we can send more of it at once, which is kind of the same thing. And right, like the point I wanted to point here, so like this is data frames, your network access layer, MAC addresses, how we start translating like, I know I've got all this digital information, but how do I physically get it where I need it to be? And this takes up a certain amount of space, right? You can see it's got some headers, it knows where it's coming from, where it wants to be, and it's got some error checking on the back end, because again, ones and zeros, did I get them in the right order? Let's run a checksum and find out, or cyclical redundancy check, I think is ultimately what it does. Right, people are pretty familiar with the MAC address, right? We've got 6 bytes of hexadecimal code usually. Often those first 3 are like assigned to a manufacturer, and the last 3 are like a device. At one point it was true. At one point it was true that that was burned in and permanent for things, but now like my phone spoofs its MAC address every time it connects to a new Wi-Fi network, so like they're largely made up things, but they identify the network device in some way, right? They like an identifier for like, this is the port or the destination I want to send my information to. This is all for same network stuff, so you're not going to see MAC addresses that are like at a remote network when it's wrapped around the packet because it doesn't understand what that means. Did I have notes here that I can't read? Possibly. Right, so how do you figure out where to send it, right? Like, so you've got this, you want to talk to your DNS server. How do you figure out where to send that packet of information? So ARP is the beginning thing, so this is the address. I wrote it down, but I've forgotten what it was. I probably wrote it down again. Doesn't matter, it's ARP. We remember what it is. Oh, thanks. So this is starting to connect those bits, right? We want to translate the physical layer, or an IP address into the physical layer. You're connecting to something on your local network, your DNS server, if you're running that locally, for instance. Like I run a Pi-hole, so it's on my local network. It has to say, like, where is this? It's going to broadcast out through your network to every system there and say, hey, who's got this IP address? And eventually the other system will say, oh, that's me, here's my MAC address. And then it can correctly encapsulate the packet and send it directly as a unicast instead of across your whole network, which is an important thing to know. Like, this is a broadcast. That's an expensive network transaction every time you're sending to every single device on the network and asking where it is. That's why your systems will have a table and cache this information so it doesn't have to do it every time. But that's a thing that happens on your local network every time you're trying to find stuff. This is important to understand where we were dealing with more physical connections, but if you had redundant switch connections and didn't have, spanning tree was the protocol, but it's probably too much for this talk, some way to be like, hey, don't keep broadcasting over and over again. If you send to every device on the network and that goes to another switch that sends to every port on that, which includes a link back to the first switch, which sends to every port on that, which includes a link back, you've just crashed your entire network by asking for where someone lives. Yeah, that was fun. Those were always fun to hunt down when someone was like, I'm going to plug this dumb switch in under my desk. Oh, I've got this extra cord. Let me just plug it back into itself. That's probably fine. And so we want to separate some of this traffic, right? Because these broadcasts can take over this whole network, how can we limit like the damage? And this is where VLANs would come in, or virtual LANs, virtual local area networks. This is how you can subdivide a physical switch. Like, because before switching, we had hubs, which was just like repeat everything to everybody, which was no good. And then we could start sending to individual places. But now, like, I don't want to have to buy a new switch every time I want to be like, well, my server shouldn't be in the same broadcast domain as all my users. And like, this other thing in the DMZ should probably also be a separate damage control. But I don't need like 12 individual switches to all handle this with a bunch of empty ports. So we can divide them by VLANs to limit our broadcast domains. This is like the protocol, if you care to look it up, of like what actually handles this. There used to be a Cisco way to do things, because of course there was, but everyone uses this one. And that has up to 4096 VLANs, because that's just how many bits you have to identify them. There's just no more space after that. Like everything, we've abstracted and like blown up the layers anyway, and there's VXLAN, which operates, I think, on layer 3 and gives us like tens of thousands of VLANs. they work the same way largely, but like with different underlying technology that virtualizes all of it. But it's the same idea of like, these systems are local to each other, these other ones are not. You can have native stuff, so like if you just plug in a switch, it's all running on like VLAN 1. But you can start tagging stuff, so that's how you can send multiple bits of traffic over the same physical port. You can send a bunch of VLANs there and do uplinks. For stuff that we work on with Equinix and providing access to like layer 2 networking of your physical machines in the cloud, you can start doing really interesting things, building routers out of that, sending network traffic all over to different systems, and like really customizing where your data goes. And this is just kind of showing it, right? Like it splits up. You can do all different things. Like there was one test here dealing with a bunch of VM stuff. We have separate public from private and vSAN networks. Yeah, just neat ways to divide up your network. So at some point, right, that was all wrapped around to find the local place, but then we've got like this IP section that goes on too. And this all has lots more information, telling it like what version of IP it is, the source address, destinations, all these other bits of information. But again, all of this, like the illustration here is to show that all of this takes up space in your data frame that you're sending. Like you only have so many bytes you can send, and a bunch of them are dedicated just to telling it where it's going. So folks are probably familiar with like the class ABC conversation with IP addresses. That also hasn't really been used since like the 80s because it ran into this problem of if you wanted public IP addresses, you could get a class C set of addresses, which was 256. If you had like 300 servers, you could get 65,000 IP addresses and no less. And if you like really needed a bunch, your next option was 16.7 million. Is that the correct binary math, I think? So like that's kind of a problem, both from a handing out IP addresses willy-nilly all over the world, and like a routing problem. Like that's a lot of IP addresses to have to keep track of locally and route to. So this is where like CIDR comes from. Whenever you're like typing in a CIDR address, you're like, why are all these slashes for subnet masks? Because we decided to subdivide it a different way. So it could be relatively arbitrary, but still be able to communicate this thing is near to me or this thing is far to me. Yeah, okay, I said that. Yeah, and that's the main point of IP addressing, is largely to say, hey, is this device someone here, or is it somewhere far away? So it knows whether to go back to that MAC address level and say, hey, is your broadcast to everyone locally, it's a local IP address, are you nearby? What's your MAC address? Or does it say, I need to go out to a router and do something else? Like, I don't know where this is, someone else handle it. It's like, we're all familiar with this. Does it, like, we know what it looks like. It translates to the net. One part of it is the IP address, and then you've got how many pieces of that are the network, and how many pieces are the host. Like, this is what it's dividing up. So that, like, 10.10.10/24, this is what it translates to when you're typing in your IP address and subnet mask. Because that 24 refers to all of those ones that just get shoved at the front of the mask. It's always broken down into binary, and it's always ones starting from the far left. So if you had a /1, it would be 1, 0, 0, 0, 0, 0, 0. And there's no other way to do it. So what this does is tell the computer, because it's all going to, again, it has to get back to bits. If the network address matches mine, that's local. Go send a broadcast and figure out where it is. If it doesn't, now I need to go send to a router. There's some special things. So like a lot of times you'll find you can't use this IP address for a machine. That's because something that's all ones in the host is considered broadcast. That'll send to absolutely everybody inside of your local network. Yeah, host bits all ones. And then there's the network address, which is the host bits all zeros. That's used for identification for routers, so you also cannot use it for your local machines. Asterisk. We'll come back to it. So you've got the notated, the network broadcast, and that gives you available hosts from 1 to 254. And then this is largely arbitrary. So as an example of like subdividing that space in a weird way, you could have a 22-bit mask, which gives you like a whole, I'm not going to do the math on how many that is, but it gives you a whole bunch more, where you see your network is now 0, 0, your broadcast is 3.255, so I guess whatever like 256 is times 3. 1,000-ish addresses. Yeah, and so you get many more available hosts. So that CIDR notation is all about giving you local hosts versus remote ones. So for instance, this is really useful if you want to build a massive cluster with lots of different nodes, like you're going to want. If you're, for instance, building a peer network between two routers that you don't really want anyone else communicating over, you probably just want two. Yeah, so speaking of wanting two, here are the weird ones. Remember I said you couldn't assign the first and last one. Turns out you can sometimes, because we were running out of IP addresses, as we have been since IP addresses. So originally, do I break them down? Yes, OK. So a /30 gives you 4 IP addresses, but only 2 of them are usable as hosts. This is the classic way it used to have to be done to have 2 different devices. But you lose broad, which is silly because there's only one other device on the network. And you lose one to network, which is also silly because there's only 2 devices on the network and no one else needs to figure it out. So it may be used for compatibility reasons or because you really like using up IP addresses. But other than that, these other 2 options are like the exceptions to the rules of what you can use that are much better. So 31 gives you 2 adjacent IP addresses, right? So it's all ones with a last bit of 0. So there's only 2 IP addresses per block. But in this case, there's no broadcaster network address involved. They can both be hosts, and they can communicate to each other directly. In 2000, to combat the dwindling IP. So for the past 2 decades, this has been available because we're running out of IP addresses still. We're out, by the way. In case anyone was wondering, there aren't IP addresses available in the public anymore. You can sublease them, but someone owns all of the IP addresses, I think except for like a handful in like... Yeah, the US government owns like many millions of them. I used to work for them, and it was very weird when I was like, these are all public addresses? Okay. Yeah, and /32 is going to give you a single IP address. This is useful for certain things like anycast IPs. You want to use a single IP address to point to a place, and you can reassign it to interfaces. It cannot be the only IP address of a device because it can't really route anywhere. Everything is remote from it. And it has nothing on its local network, so it needs some other way to communicate out. But it is useful if you need like one public IP address from a website and can point it somewhere else. Right, so that routing thing, right? Like, how do we get packets off of our local network? We know it should go to a router. Everyone's probably familiar with like filling in their default gateway whenever they need an IP address. What does that do? So, right, check network space to see if the address is local. Sends ARP find MAC address, wraps it, sends data frame to the switch to the destination directly. So that's if we've got a local address. Oh, these were my examples, right? Yeah. So my source and destination were both local, right? Because we can see the network bits are all the same. So here our source is 10 whatever, but our destination's Cloudflare's DNS because it was the first IP address I thought of. So now we see the address is remote. So now instead of sending to asking where that MAC address is, it's going to say, what's the MAC address of the next hop, which is usually your default gateway if it's like your personal computer, but like if you're dealing with weird infrastructure, you could have other routing things going on. So it's going to say, hey, router, what's your MAC address? You handle this. And so it's going to wrap that in the MAC address of the router, but the IP address of where it wants to send it. That's how it's going to travel locally, but still get somewhere else remote. And that router is then going to rewrap the packet and say, oh, here's my next upstream hop. I don't know where 111 is, but here's my default gateway. And it's going to do that over and over again until it gets to an adjacent router. Eventually, someone will be next to 111, and we'll be like, oh, and send it right along and do that. So that's how it eventually traverses. It uses that MAC addressing layer 2 to keep making a bunch of local hops, but remains with that 1111 and the IP address of saying this is ultimately where we're trying to get it. So again, all of this is like overhead. Like this is why every additional hop takes longer, not just because you're going to a new place, but it has to analyze the packet, strip off the headers, rewrap the frame, and send it along. Also why routers have like CPUs and RAM. Right. How do we know where stuff is? Routing tables. You probably also have these on all of like, your system all have these as well. It's basically saying, where IP address is this? Like, which one do I use to send it somewhere else? Most of your systems have a very simple routing table that's like, this is my local network connected to the Ethernet port, and this is my router. That's usually what like your PC's routing table will look like. A router, on the other hand, will have like, here's what's connected to me, here's my default route, here are the advertised routes that I've been told about, here's where other things are. It'll have all these different ideas of what's out in the internet and different ways to send traffic. Connected networks are one, so routers will have something that's, you've said, hey, this port is 10.10.10.0, and it goes, great, I know where that is, it's on this port. Static, usually the gateway, these are things where you tell it where the route is. And the last one is learned. Like at some point, we can't manually enter every route for every IP address on every router that lives on the internet backbone, so they need to share information with each other and say, hey, I know where that is, you can send that to me if you need it, and they advertise it all out. So this is going to be like advanced basic networking. BGP is the routing protocol that runs the internet and breaks the internet. But it is the only reason we can efficiently send packets across the globe, is having all of these interconnected routers, all advertising to each other, all of these different addresses. It has to be between peered connections, that's over TCP, so that means they don't have to be local to each other. You could have a BGP connection with something that's multiple hops away from your network, it's all over TCP, but it's directly connected to another system. They both have to agree, like, I'm going to send it to Jeremy, and Jeremy's like, I'm going to send it to Aaron. We're like, yeah, cool. There might be a password. I can also aggregate this to save space. Old Cisco routers had a limit of like 512,000 routing table entries. You'd think that wouldn't be a problem until some country accidentally leaks 30,000 new routes to the world, and then it overflows all those tables. So it can aggregate these up. So if you know where, say, like, I don't know, maybe you've got like, I'm going to use private addresses because the first one's kind of 192.168.1, and they're all 24-bit, but you know where 1, 2, 3, 4, 5, 6, and 7, like maybe that whole space, you know, the whole, even though they're different networks, you can advertise that as one address in the routing table and say, I know where all of these are. Just send all of that to me. And so that saves space in the routing tables, which turns out to be a thing. There's a lot of routes out there. This also helps determine the best route, right? Because these, our systems, like I said, aren't just connected point to point. There's not just one path to get everywhere. We have multiple paths, often a mesh, lots of different choices. What is the best path to get there? Without diving too deep into it, BGP lets you identify a whole bunch of criteria about what the best path is. So sometimes that's shortest, sometimes it's fastest, sometimes it's cheapest because you're an ISP and it costs you money to send over other ISPs. Sometimes it's locality. We send a lot of stuff through our backhaul network internally, even though it might be like normally you'd route out through public ISPs. Equinix is like, we've got a data center near there, so we're just going to route it along our edge network until it gets there and then send it back out publicly. Cheaper. We own all that infrastructure. We don't have to pay to transmit that data. So yeah, lots of reasons why you would determine what is a best route. And multiple routes can contain the same prefixes. So like multiple systems can all say like, all advertise they know where it is, even though they're all pointing to different places, which allows for some really cool stuff. That last bit is what you can leverage for lots of edge performance stuff using anycast. So you can have an application running all over the world, say whatever localities are most important to you all over the world. Every single one of those can be assigned the exact same IP address and advertised to BGP back to the public internet. So now when I ask to go to your site or app or whatever it is, and I get that one IP address, I'm going to be given the best route for me. So if you've got a server in Detroit, that's probably the one I'm going to connect to. But if someone's in Amsterdam trying to connect to it, they're going to get the server in Amsterdam that you have lit up, because that's their best path. And what's even greater is because it's all meshed, if one goes down, everything else still works. It might go slower if the one in Detroit is down and not advertising anymore, but I can still get to Amsterdam from here. So it's not broken, it's just a little bit slower. Yeah, BGP gets weird, right? Like, so understanding all of that is like, I thought pictures would be useful, and it was hard to draw and do bullet points at the same time. But this is kind of the idea of, you've got your network in a router with a BGP table, it's advertising somewhere to an ISP or someone who's got permission to advertise things publicly, and you've got that paired both with like, you're both agreeing on that connection. There's usually a password that's shared if it's not something you're setting up for fun. And again, it's not that simple because they're all interconnected, and you know, you've got your internal BGP running, it's got to route some of those out. There's some differences with internal and external BGP, which are kind of a bit complicated, but largely the gist is like internal won't keep re-advertising the networks it learns also internally, because you'd get routing loops. And again, they're all meshed, right? So like that's the challenge here. So if we, for instance, were trying to get to this router on the south, let's say it's where we're our destination, we're coming in from the router on the north, we don't have to route around the edges because we're already meshed to it. We can just go directly. And this is the example of anycast, right? So we've got all of these autonomous systems are advertising this IP address 8888. Your computer's physically closer to this one on the left, so it's going to route to that one. If you have a computer physically close to the other one, it'll route to that one. If one of them goes down, it'll still route to one of them either way. Yeah, so I'm going to try and get it right. Autonomous systems are largely the determination of like, you've got a bunch of networks. And so it's not just one network, but this whole system that advertises and understands what's going on there on its own and runs it autonomously. So you've got an autonomous system, and there's a remote autonomous system, usually given a number. There's, I think, like 0 through 65,000 are all public, and you cannot use them. Like, you have to get those specially assigned and permission, and 65,000 and up, you can use willy-nilly. And yeah, they're just ways of identifying, like, oh, hey, I'm autonomous system 5. Because again, bits, numbers are easier to work with than names. This is just, oh, this is way small for a screen. But this was supposed to show, like, similarly a ping time, showing you the idea, like, it's much closer to a bunch of different places at once, even though it's using a single IP address. And so that brings us back, right? Like, what happens when you visit a website? Well, first off, a whole bunch of stuff happens before you get an answer for who is Google.com, right? You have to, like, figure out the IP address of your DNS server. Is it local? Get a MAC address. Is it remote? Do I need to send it through a router? And that's going to all route our traffic. Maybe your DNS even benefits from, I'm sure Cloudflare is using some level of CDN and anycast to like put their DNS servers everywhere. So like all of this matters just to get the IP address of the website you're trying to do before you've even made that request through HTTP. I think this is all relevant now because we just keep building on top of this and layering networks, right? We've got like these physical systems are all doing that, and then we put a virtual system that's running Kubernetes, that's running pods with containers that all have separate virtual networks, and all of this propagates through all of those. The same patterns all the way down, it's the same stack all the way down. Yeah, I think digging into that grit helps us untangle stuff. Like I had to troubleshoot an ARP problem the other day because like, why can't I get to my gateway? Oh, because my server has no idea where that is, even though they're supposed to be connected. So yeah, it's all stuff. So thanks for listening to me. I'm Aaron, by the way. I work as a developer advocate at Equinix. I do some DevOps Days stuff and sometimes some podcast things. I'm at Crayzeigh on Twitter, CRAYZEIGH. I'd love to hear more feedback from this. Like, is there stuff that you wanted to know that I didn't dig into? Is there stuff that like is super obvious? Then like I'd love to be able to tweak this. There are slides at speaking.crayzeigh.com if you like want the reference points for any of these and download them. Other cool stuff. If you want to play with cool networking things, we've got a $500 credit code for you. You can log into Equinix and have fun and play around and do some neat networking things and see what you can do. And also, if you deploy a device before November 8th, it enters you in to win a little Lego data infrastructure platform. I wouldn't want to call it a data center. I think that's it. I was also going to put up a thing like if you wanted to work on this stuff directly, but I didn't get it in time. So you can just talk to me if that's the thing you want to do. Thanks.
Yeah, big thank you, Aaron.
Yeah.
Let's start off. Does anybody have any questions? Yeah.
Yeah.
And if you don't mind repeating.
Yeah, of course.
So you mentioned anycast as a way for things to talk to the IP that's nearest to them that matches what they're trying to talk to.
Yeah.
There's also approaches that use DNS for resolving an IP that's listened to. Could you like compare those things?
Yeah, so it's largely where is that replication happening? So if it's happening at DNS, you've got to have some logic of the DNS servers to give a different answer based on the locality of the requester. And if it's BGP, it doesn't matter. It's going to give the same answer to DNS every single time, but it's going to get routed to a different place based on the actual routing tables that are propagated through BGP. So that's doing the same thing at a different point in the route. I like the BGP way because you don't have to like maintain all these DNS records and make sure they're answering correctly. It just gives the same answer to DNS every time. You have to make sure a slightly different, complicated thing is working correctly. So.
Is there also an opportunity for staleness with the DNS approach? Not asking DNS constantly.
Yeah, I didn't dive deeply into DNS because I didn't get back up to that layer. Yes, right. DNS all has there's a level of authority with different servers, and you have a time to live on your answers. So making changes can be problematic if it's DNS. If you're like, because you probably want a long TTL if you've got a live active service with lots of users. You don't want someone else to like screw up the IP address and then not be able to set it back and cause problems. So like making changes to a DNS session could take up to 24 hours, depending on your DNS settings.
And then if I fly across the country, I might also, I have more of the questions asking is like,
Yeah.
if I cache my DNS responses and I go to a different locale, then
Yeah.
I may not actually update whereas
Right, caching will be a whole thing too, and all that. So, yeah. So yeah, again, that's why I like BGP. It's a little bit lower cost to do and less caching and complications that get thrown in. Differently complex. Yeah.
Chapter 3. And I want to go ahead and introduce our next speaker, who is Lian Li. And I love the title of this, but because I think that we all need to be focused on community. So I'll let Lian tell us all about this, and enjoy.
Thank you. First, I need to say I didn't come up with the title. I have a friend who was helping me out, trying to make it a bit more snazzy, which he's very good at. It is, right? So, yeah, well done, Ramon. Thank you very much. So, yeah, today I'm giving a talk that's not super technical, but more focused on communities, community events, because that's the other thing that I like to do. And yeah, so my name is Lian. I'm a developer advocate at Loft Labs. Right now, my colleague Rich Burrows, he's also giving a talk at the other room, which is a bit more technical about one of the tools that we built. So if you want something a bit more hard skilly, it's okay if you want to check out his talk, I allow it. Otherwise, I'm happy that you're here to join me for this presentation. All right. So as I said before, I'm a developer advocate with Loft Labs. I have been in tech about like 12, 11 years now. I'm just going to start like a little bit about myself because it like will tie into the story that I'm telling today. So I think I must have been around 11 or 12 the first time that I kind of did stuff with computers, like building websites, like built my own HTML-based website and stole some JavaScript snippets from around the internet to make it a bit more interactive. And that's when I figured like, hey, this is quite fun. But at the same time, what I really wanted to do is kind of like save the world. I wanted to like do good for the people around me. I always wanted to make things better for myself, and I realized that if you do stuff for other people, if other people are happy and content with their lives, they won't take your shit and they won't like make your life miserable. So that was something that I kind of like got quite early. I'm like, okay, so maybe the way to like do good for me is to do good stuff for others. So what I did was I wanted to become a lawyer. So I went to law school for about 3 years, and I was politically active. I was with the Social Democrats before, like when I was about 16, I joined the Social Democrats. And then for university, I joined the Pirate Party. I was a member of the student parliament for the Pirate Party, and did that for about 2 years or so. And I did that, but I always felt like I'm doing something very important, but it wasn't very fun. So politics is not fun, and everyone who's ever done anything for politics or even just is interested in it probably knows. And when you are in politics, there usually is a point in your life where you have to decide whether you want to like live your life for yourself now or live a public life, right? Like where your life is kind of in service to the public. So I decided to rather just live for myself. So I left politics, and at the same time, I also didn't want to continue down with law school anymore because I found it to be pretty boring, actually, very dry. And as I said again, it's like, it was just a constant tilting at windmills. That's how it felt like. I felt like this is very important what I'm doing, but at the same time, it just didn't give me anything. So instead, I decided to go and do something that I remembered that I liked, which was like do stuff with computers. So yeah, I didn't want to go to university again. Instead, I did an apprenticeship in Germany. That's where I'm from. And you basically go to school and then go have like practical work at a company. So what I did was I joined a games company, which is already a great start into the industry. This was a browser games company. Again, I just scraping the bottom of the barrel there. And it was okay. I mean, it wasn't the worst. There was a lot of sexism. There was a lot of racism, obviously, as a gaming company. I think that I was probably an adequate engineer. I was good enough. I mean, I could pick things up when I need them to. I can understand things when you explain them to me. But I was just never super passionate about like, ooh, yeah, this paradigm or this technology. Oh my God, I want to like spend my life just figuring that out. But yeah, it was okay. And then I went to a community event. It was like a PHP user group because everything was PHP. And I hated it. It was absolutely terrible. Not because of PHP, I mean, that's not their fault. But the thing was, everyone was super close. Like, it was a very close group. They were friends. And it just felt super exclusive. So we went to this, it was like some guy had a talk. And then the audience was like making sexual remarks. They were like, "Woo, take it off!" And the audience were women. Those are 2 women and some guy. And I mean, they were joking. It was obviously fun, but to me, it felt absolutely terrible. I hated it. I was very uncomfortable. I just didn't feel like I belong here, and this is not for me. This is obviously like a group of friends just meeting each other. So I thought, like, tech events are shit, and I never want to network because it's just terrible. So I left that company. I went to another company with people who were much more my speed, I would say. And they organized a unconference, JavaScript unconference in Hamburg. So the thing about an unconference is that the topics are not decided on in advance. Instead, you go to the thing on the day. Everyone who wants to propose a talk can propose it, and then you vote in person. You get like 2 sticky points or something, and then you vote on the topics. So, did we lose connection here? Oh, okay, I'm good. You didn't prepare that. Okay, fine. So that was completely different. Like, the people were so super supportive. I did my first lightning talk there. I did my first full talk there. And I almost cried because people were just so nice and open and welcoming. And I'm like, oh, actually, this is not too bad. And this was the very first time I was in tech for like 3 years by then. That was the very first time that I felt like I have a space here. Like, I actually felt like I belong somewhere. And people want me here, and people want to listen to what I have to say. And like, it's just something that I can give to people, and I get something back. And since then, that feeling was so important to me. It was like such a turn for me in my career that I feel like this is what I want to do for the rest of my life. I want other people to feel the exact same way, to have that thing where they're like, this is where I belong. So that's what we'll be talking about probably most of the time. And I forgot to continue my notes because I can't see them. So yeah, a bit of a disclaimer. The reason why I came up with this talk was because there were a couple of things that happened recently where community events were putting out speaker lineups, and then it was only men, for example. And I will talk about some things. I will talk about some behaviors, and maybe you feel like, oh, this is and why are you asking me now? Maybe. Could happen. If you feel this way, I invite you to just sit with that feeling of unease and affront, I don't know, and just kind of like think through why you feel this way. Instead of directly reacting, like, oh, shut up. Just like understand, like, why do I feel attacked now? Because it's not my intention to attack anyone. It's not my intention to like point at a person. But there are some behaviors that I think is very important to talk about. And the other thing is that people are very complicated, and having values and principles can also be very complicated. Like, organizers are, to me, they're the heart of our communities, or like just community organizers. And organizers are doing the best that they can, and at the same time, organizers can do better. And these might sound paradoxical, but they're not. Like, 2 things can be true at the same time, and in this case, I think both of these are true. I do think that if you do anything for the community, you understand like how much love and hard work and everything goes into it, and it's important that we respect that, and we see that as a labor of love. At the same time, it's also important that we hold each other accountable. So if you see something that an organizer does that you don't like, remember that, maybe talk to them instead of dragging them on Twitter. Like, you know, I know the likes and everything, but it's not an adversarial situation. Like, we are supposed to like help each other out in the community. So I don't see the point in like first going to Twitter and then going to the person that, you know, could change something about it. So those are some disclaimers that I think are important to just mention at the beginning before I start into my rants. All right, so communities can serve a lot of functions, and I have to read what I wrote there. So they can be, for some people, communities are safe spaces, and for other people, communities are a place where you get confronted or get inspired by new ideas and new people. And sometimes these things are kind of at odds against each other. So as community organizers, we have to kind of make a decision of where do we draw the lines. And I'm so sorry, I really need to look over there. Right, so sometimes we forget that even the smallest things can be communities or can be platforms. For example, since I got here, I've just, every single person I know or a friend of a person I know, I asked them, do you want to join us for dinner? It's a small thing, I'm just organizing a dinner. But for some people, for example, if at the beginning of your career, sitting next to Duffy, sitting next to the founder of company, whatever, this can be a place that it can turn your entire life around. It can turn your entire career around. So you can't forget how much power you have just by having connections to someone, just by making friends with someone. And at the same time, there's also some responsibility towards it. If you're going to have a dinner and there's one person who's just always a dick to everyone, maybe just don't invite that person, because you do have, I think I have a responsibility to the other people that will join the dinner that I'm trying to put on. No, Adrian is okay, he can come. At the same time also, a lot of people, when I do Twitter Spaces or something, there's a lot of people who want to get into DevRel or something like that, and they ask, some people have asked me, how do I become a member of a community? I'm like, you're already a member of the community. You're already here, you're taking part, you are filling up space, you clearly are already a member of the community, and maybe every time you ask a question or you use your voice and you take up space, you might already be a leader. Not everyone will agree with what you say, but that doesn't mean that what you say and what you do doesn't have weight. Sometimes you influence people in ways that you don't even know. And I think this is something that you should be aware of, that to me it was really getting into that speaking thing that was just it just really, as I said, just turned my life around completely. And the power that those organizers had to help me with my career is something that I think, we should all be aware of, that we could really make or break someone's career, even if we're just, going to a conference or going to a dinner. So this talk is mostly probably going to be about diversity inclusion, because that's the fancy word. I don't think it's necessarily about, your identity or what you look like. It's more about just generally what does it mean to have a good community. And the thing is that doing work specifically to improve community is really, really hard, and you have to actively decide to do it. As I said before, if you've ever done anything for the community, organized an event or something, it is really tough. There's a lot of work already, and then on top of that, you're trying to make it extra safe for people. You're trying to make it invite diverse speakers or whatever. It's really hard, and you have to actively remember to do it. You have to actively confront your own biases while you're doing it, and that can be very uncomfortable. For example, I've been following more disability advocates recently, and there's a lot of criticism that really hurts me, because I feel like, oh, I'm doing that, and I do it with the best of intentions, but I just don't have the understanding and the context to know what I'm doing is actually not helping, because I am not disabled myself. So I needed to learn how to sit with those feelings and be like, okay, this does feel kind of uncomfortable, but it's not about me, right? I'm trying to learn something about other people and how I can help other people and be an ally to people who are less privileged than I am. So really, my discomfort is not the important thing here. And yeah, it's kind of tough. But yeah, as I said, it's something that if you start doing it, it will get easier over time. So all the diversity and inclusion efforts, the more diverse and inclusive your communities are, it's almost like an exponential curve. So, for example, I'm one of the organizers of a serverless Days Amsterdam, which is a serverless-focused community that's also similar to DevOps Days. They have like a global organization and then individual chapters. And when we did the first conference in 2019, we had three proposals from female speakers out of like 70 or something. So clearly it was like, this community is just not very diverse. So what we did after the conference was we started to do monthly meetups. We tried to really actively improve the diverse makeup of the community itself. And then one of the things that I'm most proud of actually is that after like a year, we had an event with 2 female hosts, 2 female speakers, and we didn't even try to get there. It just happened. Because people were, especially if you invite women, or people of color, or people who are marginalized in some way, sometimes what they will do is they will watch some videos first. They will talk to other people who have been to your events first to learn whether it's safe or not. And the more women you have had on before, the more likely it is that you will, that more women will be feel like it's safe to speak, or like they will know that their friend has spoken there before. So it will get easier over time. It's at the beginning, then yeah, it will get easier over time. So this is the thing that I think is very important to a lot of people who are people pleasers. I once was invited to speak at a Women in Tech conference, and as I said before, I always look up a bit more information. I ask people who have been there before, and I saw that their speaker lineup was 50% male. So I asked the organizer, that seems a bit weird, because if this is about women in tech, how is it 50% male? And she was like, we wanted it to be more diverse. So they had to invite male speakers, apparently, because that's diversity in their mind. Also, they got some feedback that they would wish that more men would attend the conference. So they thought, oh, how do we get more men to attend? Easy, we get more men to speak. So I was like, I'm not going to speak at a Women in Tech event that's 50% male. It doesn't make sense. I don't think you really understand what you want to achieve. It was one woman who was organizing it. She was really pissed. Like she was like, I don't know how to make everyone happy. I'm just trying to do my best, and like I can't believe you're criticizing me like that. And I think the problem that she had was that she didn't have any core values that she could fall back on to make these decisions. Instead, she was just trying to like, maybe I should do this, maybe I should do this. Because she didn't really know what is the core mission of my event. If my core mission is telling stories of women in tech, I'm not going to invite men to do that, because how would they know? How could they tell those stories? If it's like showcasing diversity in tech, or showcasing women in tech, same thing applies. But the fact that she didn't have those core values just meant that every time she had to make a decision like that, she was just kind of like, what should I do? I don't know. Oh my God, I'm trying my best. And I believe her. She was trying her best. She was just not thinking about what exactly it was that she's doing and like what the consequences of her actions were, unfortunately. So yeah, if you want to run a community event or something, you need to think about what's your core value, what's your core mission. For serverless days, for example, we have 3 values, which is accessibility, diversity, and oh no, I forgot the third one. Damn, it's been like a long time. Anyhow, so it's just 3 of them, and then you kind of like, it's like your North Star, your prime directive. You can make all the other decisions kind of based on your 3 most important, or 2, or 1 most important. So something that follows from that idea of core values. So I learned a lot of stuff from things in the community. One of them is Kim Creighton. Yeah, she's quite well known, I think, and she's amazing, because not only is she very good at kind of like making us see the systems and the institutions that oppress people, but also she gives us the tools to overcome those systems. And one of the things that she said that really sticks with me is intention without strategy is chaos. Because there are so many companies out there who are like, oh yeah, diversity, inclusion, blah blah blah, and like put a rainbow on their brand logo, whatever, when it's that time of the year. But then what are you actually doing, right? Like, there have been more than one companies who are like, oh, we're going to put some time and effort into like making a rainbow logo. And like, okay, but what are we actually doing? Are we maybe donating money to any organization? Are we going to like showcase something out of the queer people in our company? Oh, no, yeah, that's a good idea. Maybe we should do that as well. Like, what's the actual, what are you trying to achieve? What are your core values and how are you actually getting there? And the same goes with community events. It's one thing to say we want a diverse lineup. Okay, but how are you going to get there? Are you just telling people, oh, please apply to our CFP? Fine. What happens if you still don't get enough women? Like, what's your plan B? How do you mitigate? Are you going to invite people to speak so you can be sure that you have at least like 50% female speakers? Whatever it is, you need to think about these things up front, because by the time that you realize, oh shit, we don't have enough female speakers, you are so busy with a billion other things that this is just going to stress you out for no good reason. And you know it's going to happen, right? It's very, very unlikely that you're actually going to get enough proposals from female speakers. And I also am not a huge fan of blind CFPs. I think that it's not necessarily, like the cure is not necessarily that we need to remove every single distinguishing feature from a proposal. It's like with interviews. I don't think it helps because the biases are still there. Like, even if I don't know what gender or race this person is, maybe I'm biased because they write in a specific way that sounds more academic. It's something that I'm used to. Or maybe it's because in their CV it says they went to college and I'm just more biased towards these people. It's more important that we understand what our biases are and then confront them than just trying to make every single application just like a gray blob and I just don't know exactly what kind of person it is. That's taking away from the quality of the proposal, because it's more interesting to know, oh, this is actually a person of color, so their view on this is actually quite unique as opposed to if another white guy was talking about this. Damn, I have really not set this up correctly. Anyhow, so coming to this other point where, okay, so you have a CFP open, you have like 3 women who applied, and you just don't have enough female speakers. Okay, what do you do? What do most events do? Hey, Ian Coldwater, or hey, I don't know, Kelsey Hightower. They will often go to the people who are already known, who, like the few female people that, or non-cis-abled white men, cis-able-bodied white men, straight guys, you know. Instead, they go to the people who already have so much exposure and such a big platform. And I don't think that's necessarily diverse either, because those are also not new ideas. And when you go to someone like Ian Coldwater, for example, who I really respect, it's not about Ian Coldwater, you are maybe taking away a chance for someone who has never spoken before, or someone who just doesn't have that same platform. So this is a quote from Jamila Jamil, who's, you might know her as the actress who played Tahani in The Good Place. And she's talking about, like, the media will frame, when there's like a new, I think in her case it was like a new Pakistani actress, and they were like, move aside, Jamila, there's a new brown woman in town or whatever. And she's like, no, I'm not going to move aside. You don't, like, just stand next to me so we make more space for people like us. So if you have 2 female speakers, congratulations, well done. Don't stop there. Don't say, okay, now we have the 2 token women. See if you can like create more space. Maybe now you can invite someone who has never spoken before. Maybe now you can invite someone who's not in the DevOps space, in the Kubernetes space. Maybe invite like a designer or something. Maybe they have an interesting take, right? You can always do more. You can always create more space for more diverse options, as long as you want to do that, as long as you see that and think about that. Let me just like, okay, so another thing is also, if you have a topic that you want to highlight at your event, you're like, oh, I want to, event storming or whatever, but you only know dudes who speak about that, ask one of those guys, hey, do you maybe know someone who's not a white male who could also speak on that topic? It's not that hard. You just have to like make the extra bit of effort to kind of like go one step further. and then it will, as I said before, it will get easier over time, because then you know those people and they can refer other people to you. So this is another thing that comes from Kim, where she explains kind of like the difference between diversity and inclusion, where diversity is about reaching out to people outside of your bubble, outside of your community, to get them to join and to get them to show up. But then inclusion is about how do you keep those people there. And so far I've been talking mainly about diversity, but I think the inclusion part is maybe also a part that we kind of struggle with sometimes. And I just want to check how much time I still have. 5 minutes? Okay. Oh, there it is. Okay. All right. So this is a framework that I just came up with because I needed something to put on a slide. And if you have any ideas how I can improve on that, I would be happy to hear them, because this is something that I just kind of threw together out of the things that are important to me. So ABC. A is for accessibility. Is your event or community accessible? And I don't mean, is it accessible for people with mobility issues? I mean, is it affordable? Can single moms attend your thing? If I'm a woman, do I have to go through like a super dark parking garage to get to your thing, right? There's so many ways that we are making things not accessible for other people. Hackathons that are only on Saturdays, for example, when people maybe are caretakers and they don't have time for that. So yeah, you need to think about how people who are not like me, people who don't have the same lifestyle that I do, is this still accessible for them? And of course, you can't know what you don't know, but the more you reach out, the more you learn, and the more you will see things from their perspective and realize things that they didn't even tell you, but it's just like, oh, this is becoming more obvious to me now. Yeah. The next thing is behavior. This is because I couldn't find a better B word. So what is the general vibe of your event? Is there like sexualized imagery, for example? Are ads sexualized? How are people, are they very vigilant to not use any gendered language, like guys? Are they also not use ableist language, like crazy or mad, or that will give. If I'm a person who has been marginalized my entire life, I'm gonna pick up on very minute details, and tiny things can make me feel unsafe. So the more I see that there's just a feeling of vigilance amongst the people, where it's like I don't even want to get into the general area of offending someone, that will probably make me feel a bit safer. And the thing is, if you I think I saw a tweet the other day. Who you invite defines who you disinvite. So if you want to make a space more safe for marginalized people, it comes to the cost of people who are not very inclusive. And I always feel very bad when I exclude people, because I think that's just, if I don't like someone, it doesn't make sense to exclude them in a professional manner. But if those are people who are just toxic all the time, there's a guy, actually in Valencia at Rejekts, who is just someone that I don't like, but also every single time I'm in a community with him, he's just like, yeah, you know who I'm talking about. He's just being a dick. And then he wanted to join us for dinner, and I felt really bad that I didn't invite him, but then I thought, it's not that I didn't invite him because I don't like him. I didn't invite him because he's a dick to every single person every time. So yeah, again, it's about responsibility, and it's not about punishing him, it's about making things more safe and comfortable for the people that you want to help. So what about things that are not necessarily tied to behavior, but things that really cross the line? Code of conduct stuff. So I'm going to make this a bit quicker, because most of us probably know what a code of conduct is, but I used to be part of the global code of conduct team for Global Diversity CFP Day, which is a one-day workshop that aims to help marginalized people come up with their first tech talk. And because we were aiming specifically at marginalized people, we knew that we had to be extra vigilant to be sure that they're safe. So what we did, we developed a COC training and wrote down some scenarios so people could already kind of act out the situations in which they would have to act on COC violations. And the basic rules are, make sure that there's people who are dedicated to COC to take like reports for COC violations, because everyone else was going to be busy. Make sure to listen to the person who reports. Ask them how they would like to have this handled. Like, be transparent about it. And if you also make it public, then this will also signal to other people, hey, we're taking this very seriously, and you can feel safe because we really understand this is important. So yeah, check those out if you are interested in that. And oh, here we are. This is like, take a picture of this. Make the COC very visible throughout the venue and during your events. Clarify what will happen if you violate the COC. If you can have multiple channels to report incidents, go for it. The more, the better. Yeah, dedicated COC folks. Someone reports, focus on them, and be transparent. I already said that. All right. Okay. I'm just gonna just don't make it about you. It's not about you. It's about the community as a whole. If a thing hinges on one single person, it just doesn't scale. And this is what I did wrong a long time. I just tried to march on because I had this vision, and I just felt terrible. And then as soon as I kind of like focused more on the community, focused more on like small things, improving small things for people around me, the easier it got, because people would then give back to me, give that energy back to me, and together we were able to do something greater than a single person could have ever done. And that is the end of my talk. I'm just going to say, go and check out Kim's new book, Profit Without Oppression. It's going to be amazing. Kim is amazing, and I cannot thank her enough for giving me all the kind of input for this talk. Thanks. Have a drink.
So I'm going to recommend that people meet Leanne out in the common areas over the rest of the day and ask questions there, because I think you made awesome points fundamentally about we're all learning this together, and hold back judgment, especially if you're feeling attacked.
Yeah.
But there will be plenty of moments to ask her questions over the course of the day. We've got about 7 minutes until our next talk, so do the swapping, the bio break, the get your snack, and let's say thanks again to Leanne. Thank you.
Thank you.
So welcome back, everyone. I hope you had a lovely wander downstairs or momentary rest to collect your thoughts, etc. Our next talk up is everything you wanted to know about Kubernetes RBAC, and this is Ben Hirschberg. Thank you. Please welcome Ben.
Can you take a photo of me? I was asked to.
Yes.
Yeah.
I
So,
can totally take
during
photos.
the spontaneously, like. So hi everyone. So just before we start, okay, this is going to be a. As at first, there is going to be a basic talk about Kubernetes RBAC. Then we'll go into some more interesting things. Just a few words about me before we start. I'm Ben, one of the maintainers of Kubescape project, and also CTO at Armo. Originally, I started my career from the security side of the industry, and gradually moved into cloud native, and one of the organizers of CNCF in Jerusalem in Israel. Yeah, this is about me. Okay, so as I started to say, we're going to do some one-on-one on Kubernetes RBAC with a few very specific examples. Then, as I wrote, we'll do 102, which is like more of how we are writing Kubernetes RBAC when we need to maintain it. And then I will bring you a few issues, okay, as part of the things we are seeing, in Armo, in live Kubernetes clusters of issues with RBACs. So let's go inside. Let's start. Okay, so basics of Kubernetes RBAC. So Kubernetes RBAC is actually, a feature of the Kubernetes API server, and I guess as most of you know that Kubernetes API server is the main contact of control of the Kubernetes control plane of any user of Kubernetes, and actually the API server has a few ways, okay, not just to authorize actions, okay, but also to authenticate you, and it is important to understand how it works, okay. So when you're talking to API servers, there are two main ways to identify yourself against the API server. One is mutual TLS, client authentication by a certificate and proving that you have the private key. Okay, so when you're turning to the API server, actually you have to prove to the API server that you have the private key connected to your certificate. The second is single-sided TLS from the API server side, but you have to provide a token and connect it to it OpenID protocol and so on. So in other words, you're bringing a token with you and prove who you are with the token to the API server. But I have to tell you, in both cases, okay, and I'm not talking about static password because it's not worth talking. But in both cases, from a security perspective, obviously it's very important, okay, to rotate keys because you're going to see that actually all of these keys, from our perspective, okay, it's very important. So the API authorizations are ways. There are several strategies. Okay, RBAC is only one of them, but I have to tell you that Kubernetes RBAC is the clear winner. Okay, here Kubernetes RBAC is the way today to manage access control inside a Kubernetes cluster. Now, how Kubernetes RBAC is built up? Okay, I'm sorry if you don't see it right. Okay, but there is a role definition. The role definition is actually what this role can do. Okay, and it's very bound to the structure of the Kubernetes API, in the sense that all of the parameters which you can control in a role and you can limit with the role is actually coming from the HTTP header. Okay, and more of the first line of the HTTP request. So where you have the path, the API group, the resource you're turning to, and the HTTP word. The second part is the subject. Okay, the subject to who you are giving a role. Okay, it can be a user, it can be a group, and it can be what we call a service account. Okay, which is actually a special user from inside the cluster, managed by actually the cluster itself. And these two are bounded with what we call a role binding. Okay, So we can say which role can be used by which subject. So I brought here a few examples, and here there is a little demystification, okay? Because sometimes we are not looking inside these artifacts. So from a subject perspective, I brought here a certificate, okay? X509 certificate, a very standard certificate for which I'm using in this case against Minikube to authenticate myself. And this certificate sits on my in my home directory under the .minikube directory, and it is the certificate format is the same as you would have like if you're using Amazon.com to buy something. But the interesting part is this line, the subject. Okay, the subject has which is subject in X509 is the one who this certificate was assigned to, and it has two sub entries. One is the organization, okay? System masters. Organization translates from X509 to Kubernetes API server authentication as the group, okay? And the common name, CN, is Minikube user, which is the user field. So this is the user, and this is the group. So if I'm authenticating myself against the API server, okay, from these two fields, the API server understands who it is talking to, which user and which group, okay? Now, I brought you an example of a role, okay? A cluster role in specific. And the interesting part is the rules field, okay? The rules field is actually where I'm describing what is allowed to do, what this role is allowed to do. And you can see here the API group, the resources, and the verbs, okay? These are three things, okay, which mostly, okay, there are other things, but in this case, to simplify it, these are the three basic things, okay, which are defining a role. Okay, if you are putting in these fields a wildcard character, it means that everything is accepted. So you can understand from this that the cluster role is pretty permissive. Now I'm showing you something a little bit more interesting, another cluster role, okay, where actually the resources are listed explicitly, the verbs, the HTTP words, which can be the list and watch, listed explicitly, okay, and you can define as a list of rules, you can define these triplets, okay, in order to define a role inside the Kubernetes role-based access control. Okay, the binding object, which, as I told you, is connecting together the user group or service account, the subject, together with the role, is actually has two interesting parts: a role reference, okay, to which role I'm binding, and who are the subjects. So in this case, there is a role called Grafana, guess which to who it belongs to, and the service account Grafana, okay, in the namespace default, where it is bound. So we have bound this role to the service account of Grafana in the default namespace. Another example, okay, which is from, I think also from my Minikube, okay, is simply the most basic and most, I think, important user is the cluster admin, okay, where the cluster admin role is bound to the system masters group, okay? Everyone who is in the system master group can use this cluster admin role, and if you recall, that was the rule with all these wildcards you saw before. So now a very short one slide introduction to the Middle Eastern languages, okay? Which is not related, but I think it's really fun to, after we've heard so much dry information. So every Semitic language, when they are building a word, okay, they're using 3 consonants. These are the root consonants of every Semitic word, both Hebrew, Arabic, and other Semitic languages. So if we are looking at RBAC, okay, in case of RBAC, these consonants are R, B, and C, right? So if I'm writing down in one of the Semitic languages, okay, and I'm trying to read it, okay, because these languages are also extrapolating, okay, the vowels, okay, I get Rabak, okay? Now the question is there anyone who speaks Arabic or Hebrew? Nothing? So what does it mean if I'm translating this word to English? damn. Okay, so this is just a short thing. Okay, but actually, damn is just a a more light translation. So rules of writing RBAC. So obviously, like in every access control system, the most important thing is to apply least privilege principle. Okay, every actor, every subject has to get the least privileges. It needs to complete its own work. Now, in case we are talking about services which are running inside Kubernetes and they get service tokens, okay, what we should do is, for example, in case of someone writes a Kubernetes operator under Kubernetes, obviously we would list, okay, the pods, okay, the config mask or what actually it needs to access through the API server, which are the resources it needs to complete its job. Now we need to list also what are the verbs it actually needs, okay, and then we are creating a role, and from this, okay, we are binding this role to the service account we are going to give to this service. Now usually it's more simple, okay, because in case of operators and different kind of actors inside the cluster, okay, it should be pretty clear for the maintainer to understand, okay, what kind of object it needs to access, what kind of verbs it's going to need. So it's straightforward in the sense that you can limit really its access to only things it needs. The question stays, okay, that what kind of things it's going to need to access, and obviously if it's going to need to access multiple things, then we have to limit the access to its service account. Now, if we are talking about assigning RBAC to actually operators, or users, or SREs, to DevOps, and so on, okay, it's going to be it's going to be way more complex, okay, because it's not always clear, okay, what the users need, and here from this point of view, Kubernetes RBAC is nothing different from any kind of access control system and its management problems, okay, that you will have. You will start with giving someone few privileges. Then it turns out that one day it needs a little bit more. You add it, but then you're forgetting to remove the privileges you needed for once, and you leave it from there, and you start to copy it, and so on, so on. So it's it is not easy. But here also you have sometimes more simple decisions like external users like the CD tools, okay, which need to able to spawn things inside the Kubernetes cluster. But in any case, okay, the last comment, okay, using wildcards inside roles is usually a bad sign, okay, and you should limit this. So, okay, this was the first two parts, okay, I would say for first half, okay, of the discussion. We get some to the same, level of understanding what we have in Kubernetes RBAC. So now let's talk a little bit about issues, okay, around RBAC and things we see out in the wild. So, first thing, okay, is what I want to talk about: privilege inversions. Who have heard the word privilege inversion before? I thought that this is an existent. Have you heard? Okay, because I thought that this was this was a thing, and I was convinced that it was a thing, and it turned out that if you are looking at Google, okay, we are writing privilege inversion, okay, there is no, you don't find anything that that shows that the same understanding as I have. Then I understood why, because actually I came for long years. I was writing in real-time operating systems software, and there is a thing there you call priority inversion. I don't know. Yeah, you heard about it. So right. So somehow it looks like my brain just translated these things. So from now on, from this discussion, you understand that this is a thing. There is a priority inversion. Okay, priority inversion is actually is this definition of inadvertently assigning privileges, okay, to a subject which should be covered by other privileges. Okay? And example, very simple example of it. There is in role, there is an access to an API called exec inside pods, right? I think most of you heard about the exec API. So obviously this is it's as an entry inside the role, and let's say that there is a user, okay, a subject called A, okay, who has this exec privilege on pods, but he doesn't have any other privileges inside. So theoretically, he cannot create pods, he cannot delete secrets, and so on and so on. Just only can exec. So let's say, okay, that subject B is a service account, okay, with the deployment delete privileges. So there is a subject B, okay, with a service account, and it is allowed to delete deployments, right? And now the interesting thing comes. Okay, the subject A opens a shell inside on a pod which has the service account B mounted inside, right? And what's going to happen? Okay, since there is a service account with a service account token inside, we see that subject A can delete deployments, though we never gave this permission to it. But in practice, it can delete deployments, right? And this is obviously if someone has an exec, I can prove to you afterwards that if someone has an exec privileges, okay, mostly have a cluster takeover case anyhow. Okay, so this obviously bypasses the role of deployment delete. Okay. Well, yeah, it's a kind of privilege escalation. Yeah, sure. So it's interesting. Okay, it's a screenshot. I don't know if you see it right, but it comes from KubeScape Cloud's own RBAC visualizer. Okay, and what you can see here is the resource. Okay, here are the cluster roles. Okay, and here are the actual the subjects. Okay, which can access these. Okay, and you can see that inside one of the clusters. Okay, I saw that who has exec privileges on every pod resource. Okay, and obviously cluster admin has access. KDE operator, okay, also has exec on everything, which is not really I'm not sure that is right. And also Velero server has access on everything. Kind of fishy, but okay, this is something, okay, that it doesn't seem right. Okay, and if you're looking at all those users, okay, and groups who have access, okay, this doesn't really look good in practice, and I think it is the same simple EKS cluster, okay, with a few stuff inside. Another example, okay, and this is a little bit more complex of example of privilege escalation or inversion case. Okay, subject A has a create privilege on pods, no other privileges, nothing. Okay, subject A creates a pod with a Kubernetes secret map inside. So if I am able in Kubernetes RBAC to create a pod, I'm allowed to map inside any secret which is inside the same namespace, right? Now, I can create this pod with a simple curl command, which takes this file, posts it to my server. That's it, right? And obviously, when I have a pod creation, okay, pod create role, okay, I can have access to any secret. I have a config map. I can connect to any PVC, and so on and so on. And honestly, this is not so good. Okay, we could, find ourselves a few, we could say to ourselves, well, exec, we are not giving to everyone exec privileges, but I'm sure that pod creation is given to everyone, okay, to every CD tool, everyone who is trying, because actually this is what we are doing inside Kubernetes. And obviously, by the way, it's not just pod create, it's pod update, the same issue. Okay, okay, again, this doesn't look good. The same idea here. Okay, I was checking who has pod create privileges in the same EKS cluster. You can see that everyone, okay, a whole bunch of things. And if you are interested in RBAC, okay, go to Kubescape Cloud, okay, and just play with it, okay, it's fun, okay, you're starting to find different interesting things around it. Everyone has access to it. So actually, what is the answer to, okay, what is the answer to these kind of things? Because since RBAC cannot take into account the actual content, okay, of an HTTP request, only the first line of the HTTP request and not the pushed structure, the object, okay, we have to rely on admission controllers. So RBAC is great. RBAC isn't that complex, okay? It looks frightening, okay, but it's actually it's way simpler than I like it inside. But on the other hand, if you want to have fine-grained access, okay, of your Kubernetes cluster in the sense of access control, that who you are letting to do what, okay, you must have an admission controller. Because I haven't even talked about, okay, someone who has a pod creation privilege, okay, can create a privileged container, okay, who have all the node accesses, and you can map the whole node root file system inside, and you have all the node secrets and everything. So it is really important, okay, extending in production systems, extending Kubernetes RBAC and authorization and access control with an policy engine like those. So I don't know how much time I have still. There was a question. If I recall, it was coming from Palo Alto Networks. Some stage, okay, whether container escape equals cluster takeover, okay? And where they come from is that they said that, well, one thing that we are writing operators for our applications, okay, but other thing that actually cloud vendors and the whole way of how Kubernetes is built, okay, and I have to tell you that I'm not complaining, okay, I actually love it, but the way it was built, it's really caused many vendors to build different daemon sets and components inside their Kubernetes deployments, which have very high privileges, okay, and really high roles, okay, and all this is true for many components, okay, not just the cloud vendor, but also for other infrastructure components, okay, and what they asked is, okay, if I am able to penetrate as an attacker, able to penetrate one of these containers, okay, and access to his service account, whether can I take over the cluster itself, okay? And in this example, okay, I took the AWS node cluster role, okay, which is obviously used by AWS node daemon set in EKS, but I could take the same thing from Google, okay, and from Azure as well, and you can see that it has an extensive access, okay, to different resources, okay. It can update nodes, okay. It can create list patch, and also, by the way, delete Kubernetes events, okay. Which is great for an attacker who wants to clear up, okay, his traces, okay. Obviously can, access pods, though I don't see that it can create pods, okay. It can get list watch namespaces and so on, but and also can watch every resource. So, in the sense, okay, of generalization, okay, this is. I'm not sure that this is so bad as they told, but it turned out that when they raised the same question was like 3 years ago, okay, which were like the early stages of all these projects of EKS and so on. And it turned out that they had much more privileges, open privileges, which were not used, and actually cloud vendors made a job, okay, to really tidy it down and really add least privilege principle, okay, to these things. But okay, if in general, if someone, and this is not really related to the same question of daemon sets, okay, high privilege daemon sets, But if an attacker is able to escape a Kubernetes container inside a Kubernetes container to the node and can access the file system, okay, what will he find there? He'll find there the kubelet's own secret key, okay, which it uses to connect the kube API. It means that automatically he will, inherit all the privileges of a Kubernetes node and a kubelet inside. Okay, it will also find maybe also the bootstrap token, which is another precious part, okay, in a Kubernetes cluster. So if someone is able, if a single container able to escape, escape the attacker is able to escape a container inside the Kubernetes cluster, it has a pretty high privileges. And there was an extra work, okay, which was done in order to filter out many other things of which a Kubernetes node can done. Okay, and the last question, for which we have still a few minutes, okay, is actually the question of who should use cluster admin in a Kubernetes cluster, okay? Which is you saw that cluster admins are has access to everything. They can do whatever they want, okay, against the API server, and in general, okay, just like in any other case, okay, their use should be limited to close to 0, okay, which is not an easy thing, okay. But okay, I do have a controversial opinion about this, okay, because people are really talking, and in many blogs were written about how to limit cluster admin access and how important it is, okay, to create users for each DevOps engineer and each CI/CD tool and so on. My controversial opinion is that, in case, okay, I'm fine with the principle of limiting cluster admin, but if you are any cluster user, okay, who can create pods, okay, can steal your secret, can take over the nodes and so on, okay, what are the point of limiting the cluster admin access? So first, okay, if you're thinking you have a cluster you want to secure, okay, if you have to decide two things, whether I'm starting to create for every DevOps engineer, creating a different admin access with different namespaces to them, assigned to them, and or applying, taking an admission controller which starts to limit, okay, these things, I say to you, and it's controversial, okay, start with an admission controller, start to limit those things. Obviously, store the cluster admin, okay, protect it, but just after, okay, you've set up your protection around the cluster, around your cluster with an admission controller, afterwards start to invest of creating, okay, different administrative users, okay, for the Kubernetes cluster. So just really a last word, okay, we are the KubeScape team from Armo. We, in KubeScape we are investing a lot of, how to manage RBAC, both from the CLI, how to find out issues around RBAC, and the visualization tool we have on our KubeScape Cloud site is really neat, okay, and I suggest you have a look at it, okay, and I really, if you want to have any questions, I'm here still afterwards.
Do we have any questions in the room?
Yeah, sure.
So you were talking about secrets and those getting elevated by, or getting access if you could put in a pod.
Right.
Now that should be limited by the namespace you're in, right?
So
So you don't be able to get access to the secrets in your namespace.
yeah.
Okay.
Yeah, but I have to tell you that if again, just think about it, you're right, okay? If I'm creating a role, okay, which can create only within a given namespace pod, okay, it should be able to access only the secrets inside that pod. However, you can create, right, a node. You can map. You can attack the node by mapping inside, okay, the volumes, okay, of the host, okay. Use the secrets, okay, of the Kubernetes node to access the API server again, and you can bring every secret from there because Kubernetes nodes must have access to the Kubernetes secrets. Otherwise, they cannot bring them in to the onto the pod, map them into the pod. So it's yeah. So this is why I would say that I'm again open. First of all, as an admission controller, and protect your Kubernetes node. And only let very, very specific give exceptions to every each deployment or daemon set which must access the node volumes, and just after that start to afterwards the other things.
Controversial opinion for sure.
Yeah.
No, it's good. It gives us thoughts, gives us things to discuss. Did you have a question? No, okay. Other questions, or off to a quick little break, reset, and downstairs or upstairs as you swap? You got one more question. All right. Yeah. Oh, great T-shirt. All right, nice. Don't touch my YAML. Excellent.
Yeah. Thank you very much,
thanks
guys.
so much. Have a great.
Who's not here yet?
Well, he was here.
Who?
Dave.
Me. That's me.
Hi. It's lovely to meet you.
Sorry, I took my mask off.
No, it's okay.
Yeah.
Sarah local time.
It's okay.
Hi, Dave. So I've recently been introduced to our new speaker, our next speaker. Well, welcome back. It is 3:40 in this particular time zone. Don't know where my brain is, but that's fine. We're here to hear from Dave Smith Uchida, and he is speaking on custom resource-based APIs. And here we go, Dave.
Thank you. Okay, is my mic work? Yeah, cool. Thank you for coming. I'm Dave Smith Uchida. I work for Kasten by Veeam. Ali Dower also co-authored the presentation, but unfortunately he can't make it here. I've been working with Kubernetes, I don't know, 4 years now, I think. I spent some time as the Valero lead and doing a lot of data protection stuff. So I've built several custom resource-based applications at this point, and wanted to take a look through what, building a custom resource-based, if it's the right approach for you. There we go. Okay, so just a quick, some of the stuff I want to cover here. We'll talk about what it is, some examples, declarative APIs, which are tricky to get right, a little on security, parallelism, performance, some ways you can implement an application. We put together a little example with a CI/CD pipeline, and then data protection, which is near and dear to my heart, and then some conclusions. Okay. So what is a custom resource-based API? So this is one where your application needs a way to interact with something, but it doesn't actually provide an API endpoint. So there's no REST, no gRPC being provided by your application. Instead, clients will talk to your application via changes to Kubernetes resources. These could be custom resource definitions. That's a pretty common one. It's possible there's another path called an aggregated API server. I'll cover how that works later on. And you can even just do things with, like, say, config map. You can write out config maps of certain types and have your application watching for those. So how does an application like this work? So this is pretty much the standard Kubernetes model. So it's going to, so your client, or user, changes the resource to reflect what they want. That's your desired state. And then the controller, your application, is going to look at what's out there in the Kubernetes resources, look at the state of the world, and try and bring the two into sync. That's the basic idea, this reconciliation. And then it'll update the resources with the status of the real world, and that's how you find out what the state of the world as the application thinks it is. And of course, there's relentless forward progress, which means that your controller should keep retrying things. You say you want something done, it hits an error, it should retry this periodically until it eventually gets there. And that may allow you to, for example, fix other things in the system so that things can work. So there's some patterns we've seen so far of applications that use this pattern. So I'm going to split out the idea of a Kubernetes operator. In my terminology, I narrow it a little bit because you'll see some definitions that are basically any custom resource-based application is an operator. I narrow it down a little bit to say that it's really something that is managing resources for you and being controlled via Kubernetes. So an example of this would be a database operator like the Postgres, multiple Postgres operators, where you tell the operator, I want a Postgres database, and it does the work of creating the database, but your application, the operator, isn't the database. So it's not actually providing the service that it's managing. That's a very common pattern. If you are implementing an operator, then by definition, you're going to be doing custom resources. So we're not going to go into the pros and cons there because you've already decided that you want to be able to manage a service via Kubernetes. A lot of things we see are system utilities, backup apps, for example. And these, you're controlling the application via CRs. So this is really the model of an application, but these tend to be very Kubernetes linked and very specific to like controlling or protecting Kubernetes. But the model of the application is pretty much the model of a general purpose application. And then there's general purpose applications. And when we did the proposal, we're like, oh, hey, lots of people must be doing these. And then we did the proposal, and then it's like, hey, you're accepted, hey. And so we looked, and it's like, actually not that many people are doing that. But we're going to talk about some examples of things you might build. And I suspect there's an awful lot of things that are internal that we don't see when you Google for applications. But so an example of this might be a CI/CD pipeline that is controlled by Kubernetes resources. We had a thought of doing something for like a trading model testing where you could write a resource saying, hey, I want to test my new model, and the application goes, spins up a few pods, runs your model for you, gets the results, and puts it back there. So those are some possible things. I'm sure people will come up with other things. So if you're putting things together via Kubernetes, declarative APIs are kind of it's the way when it comes to Kubernetes. And a declarative API is where you say, this is the way things should be. You declare that by writing it into the resource. And then the system's responsible for making reality match up with what you wanted. So your desired state and your actual state. This is really different than imperative APIs, which is what most of us worked with for a long time, where you say things like, do this. So for example, say we have a system that's managing a warehouse. You may have an imperative API that says, move box A to shelf 5. When you make that call, it could be a REST call, it could be gRPC, it doesn't really matter. When you make that call, the system is going to go and do whatever work it needs to do to move the box to shelf 5. When it gets there, when it either hits an error or it completes, it comes back to you and it says, hey, I did this. Now, in a declarative API, you're going to say box A is on shelf 5. And then you kind of wander off. You can watch it if you like, but the system's responsible for getting things onto shelf 5, getting that box on there, and it may retry. You know, say for example, it's controlling a robot, the robot fell over, somebody fixed the robot, let's try it again. That's all happening in your reconciliation loop inside the controller. It's not the client watching and saying, hey, I told you to move it, oops, that failed. Okay, let's try it again, let me do an alert. That's a big difference there. So when we go and implement these applications, it's pretty common to actually wind up where you put the actions in and you put them in as resources, and you say, for example, like we might have a move box action resource. And it works, but there's a lot of pitfalls with it. So like in this example, we have, say, move box action. Each resource, so every time you want to move a box, you'll write a resource. You name the resource something, and it doesn't really matter what it's named, but it has to be unique, otherwise you're going to run over other things. And you put in the spec, you put what box you're moving and what shelf you're going to. And then the status would be updated with succeeded or failed, or other error conditions. And so basically what you've done at this point is you've taken your RPC and you've changed it to a different transport mechanism, and you're pushing it through Kubernetes resources. And this has a bunch of pitfalls if you do this. So things like order of execution. So 5 people wrote move box A somewhere. Which one goes first? Which one comes second? That's a question that you have to figure out. Where is the box? This resource doesn't tell you where the box is. It tells you an action that was taken, whether or not the action succeeded. But if you want to know where the box is, and you do it through the Kubernetes API, there's going to have to be a resource somewhere else that says box position that you can read. And then you wind up with cleanup. So since you're writing one of these resources for each action, they tend to proliferate. And they're not very useful after you've written them. So somebody needs to clean them up. However, they're also the way that you found out if this API call succeeded. So if you clean it up prematurely, the client doesn't see it. So say you have a long-running application, took an hour to move the box. Your client, wandered off, it's in its retry, backed off a bit, and you clean up the resource, pick a time. Does it clean it up in 5 minutes, an hour, a day, whatever? You have to pick something there, and there's a point where, it's always possible for the client to never have seen the result because the resource got cleaned up. And then something's got to clean them up as well. So you have to write a little loop in your server, in your application, to go and clean things up at certain times. So even though this is the way, I'm going to tell you, no judgment, I've done this, right? So why did we do this? So for example, we had things that we wanted to expose user control, but we didn't want to build a new API endpoint, like a new REST endpoint that had to be exposed outside the cluster. We said, yeah, this is a utility. The user already has Kubernetes access, so we're going to run it through the resource things, even though this is kind of busted. We've had things where we wanted to have a publish-subscribe mechanism for running operations, and it's like, yeah, it's easier to run it through the API server rather than writing our own mechanism for distributing things. So no judgment, but just be aware of this going in, that if you start writing these kind of actions, it looks simple at the beginning, but you've got to deal with all these other issues. So if we were to do the same example as a declarative API, instead you'd have a box resource. You have one of these for each box in the warehouse. You put a name, the name of the resource is the name of the box, and your spec is the shelf that you want it to be on, and in the status you can have the shelf that it's actually on, and you can have some conditions for what condition is the box in. Is it settled? Is it moving? Are we retrying it, etc.? So why is this better? And better is really in terms of better fits into Kubernetes, the Kubernetes model in this custom resource model. It's not declarative APIs are simply better than imperative APIs. But if you're doing this, if you're doing the Kubernetes model here, it's better so you've got the name of the resource identifies the box. Makes it a little simpler. You didn't need to figure out what to name the resource. You didn't have to worry about name collisions, which we did with the action, because each action had to be named separately. Order of execution. Whoever was the last writer, whatever is there in the resource is what's going to, where it's going to go. So if somebody writes, 3, then somebody else writes 4, and somebody else writes 5, it doesn't really matter. You can short circuit all that. You can go straight to 5 because you don't need to do all the intermediate things because you're not talking about, these are not actions, these are where I want it to be. So you can potentially telescope all of the actions down together. You only have one resource here. So you've got the resource that tells you what the position is and controls the position. So before we had an action resource and we would have wound up with a per box resource. And then your reconciliation in your controller is simpler because all you do is you look for differences and try to resolve differences. You don't have to worry about cleanup. You don't have to worry about order of execution. So given that you've done your API design and gotten your resources into Kubernetes, security is another standard issue. And I tend to say RBAC when I mean Kubernetes security. And if you saw Ben's presentation before, there's a whole bunch of different ways that you can do Kubernetes security. But the key thing is that if you're going through this resource model, you're leveraging all of the stuff out of Kubernetes in terms of security and so forth. And you get an existing security model. It may be a complicated one, but it's there. And people can, it's being studied and you can understand it. Authentication, you've delegated out to the API server, so you don't have to have authentication in your application. Now, the bad things from a security point of view is that your users need to have API server access. And in my opinion, I would not give out API server access to just anybody because there's just it's not designed for it. It's kind of like giving users SSH to your Linux host. It's like, I'm not going to do that. You could potentially put a gateway in front that handles this, but then you've taken security back to yourself, so you're really not winning too much there. But assuming that you've gone ahead and done that, what are some patterns that you can do? So one way is you just put your app and the CRs in the same namespace. You give users who are allowed to use the app, you give them access to read and write these resources in the namespace, and you're done. It's pretty easy to set up. It's a very coarse-grained control, but it depends on what you're doing. It may be just fine. Another way is you can actually set RBAC rules on individual named resources. So you can say they can read and write this specific resource. We've tried this, and it almost works, but one of the problems that you have is things like discovery. If you don't know the name of the resource, you can't really list things out if we've limited their access down. Another way to do this is you take the first model, but you add multiple namespaces, and then you limit access on a namespace access on like a per user basis. And this way, they can just read and write. Users can just read and write resources in the namespace that they're allowed to write to. You'll see this pattern in a few places. This is something that VMware was doing. And this works out okay in some ways, but it makes it harder in your application because now you have to monitor for changes in multiple namespaces. And you may want to do things like limit which namespaces the application is watching so that random people creating random namespaces can't suddenly start doing things. And then you also have to be careful of these privilege escalation paths. And that's true everywhere, but we've been hitting it more in this namespace per user thing because often we'll have the controller running in one namespace. It has some resources in there that get referenced from individual namespaces. Like, okay, how do I make sure that there's no way to guess at a resource that I shouldn't be able to see and have the application do things on my behalf using a resource that they shouldn't be using. Okay, so we've gotten our security concerns out of the way. One reason to do this is also you get a fairly easy parallelism model. So you've got multiple workers, you want work to come in, you want workers to work on things. And so we've got some different common patterns. One would be a dispatcher with multiple workers. There might be a load balancer or something. It's one way to do it, kind of hard. You might have a queuing system to distribute work out to the various workers, or you can do publish and subscribe, where various workers are watching for things. And the publish subscribe model actually fits in nicely with a CR-based application and with Kubernetes. So if you do that, how does that work? So this has the advantage that you're leveraging the Kubernetes API server. The resources are all there. No extra code to do that. You don't need a queuing system. You don't need a dispatcher. You can just have your workers contend on the resources. You need a locking mechanism. So you can lock a resource, and if the resource is locked, then that worker works on it. Everybody else says, oh, it's locked, I'll leave it alone. And then the lock holder does the work and releases the lock. The locks need to expire. So like, for example, if a worker crashes, then the lock should expire, and then everybody should recontend on the resources and get back to work. I've done this. This actually works out fairly nicely. Okay, so you figured out all these other things. How about, scale, and what are your scale requirements, and is this right for you in terms of your scale requirements? So one of the big issues with the API server is it doesn't handle large numbers of resources well. So we're told, let's not do that. So if you have, the warehouse example from earlier may not exactly be a very good one because most warehouses have more than 1,000 boxes in there. So you have to look at how many resources you're planning to put into the API server before you start coding this, because you don't want to have to go through and undo the whole thing. An aggregated API server can help with large numbers of resources. I'll go through a little of how that's built. You really shouldn't have a large number of simultaneous clients to the API server. And then in terms of performance, just in terms of looking at this as an API transport, your basic operation for getting your application to do something turns into a whole bunch of stuff. You have to write the CR, which means you're doing an etcd write, then the controller has to be notified and wake up, then it actually does its work, then it has to update things back into the resource, which would be again an etcd write, and the client has to be woken up to read things. So we did some basic numbers on this to give you kind of a feel of this. These are not rigorous or extremely scientific, but they are a little interesting. So we did some stuff with we built a small application that's just a kind of a dummy that updates things. We use kubectl to write and read resources for the application. We ran this in Google Cloud, pretty standard configuration, GPU storage, 3 worker nodes, a couple management nodes, and we measured things like how long does it take for things to happen. And I kind of thought they were bad, but this is actually worse than I expected. So your basic time here that we measured was time to create a resource was about 270 milliseconds. And that's getting it down into etcd. And then the controller took some time to be woken up and to read the resource. That was an extra 400 milliseconds. Now you're actually doing work. In this case, we didn't do any. But we just wrote back that we were done. And so again, it took us 270 milliseconds to update the resource. And then it took another 400-ish milliseconds for the client to see the change. So without actually doing any work, we've already consumed 1.4 seconds. So this is, and there's areas where this is not a problem, but there's definitely areas where it is. So you really need to understand the performance that you need out of your API before you go into this. Because if you've got something that takes 50 milliseconds to execute, you'll probably be very unhappy going through this. So, here at the middle, we can talk a little about, what did we think about these APIs. So what's great about building something this way? It leverages all the Kubernetes stuff. You get the RBAC security, all of the operations, the CRUD operations are all done for you. You can use existing clients, and you can use kubectl. You can write. You can use the Go client and put a wrapper around that. All kinds of great things there. Scaling your app is fairly easy. If you follow the pattern, you can run multiple controllers. You don't have to do too much in order to distribute work out across them. And one of the neat things is that because you've fully disconnected the client and the application, if the application goes down, clients can continue to modify resources. As long as the application comes back in a reasonable amount of time, the client never notices. So that's some cool stuff. On the bad side, well, number one is you are now tied to Kubernetes. So if you think that you're going to switch to some other system for building and running things, you're going to have to redo your API. The declarative API doesn't always work. You may look at it for a long time and go, it's just not going to work for me. Number of resources, again, that's an issue. And performance can be a very big issue for you. So we've now gone ahead, we've decided that we looked at all of these issues. We said, yes, we're going to go ahead and do it this way. Now, how do you actually build something like this? So there's two common ways to do this. One is to use custom resource definitions and controllers. And this is good. So basically your schema is there in the CRD. You register it with Kubernetes, with the API server, and that allows you to read and write resources. And you just run the controller. It talks to the API server. It sees things changing. It's pretty easy to implement. Now, another way to do this is with the aggregated API server, where you actually write a server, and I'll go into a little more detail on this, that serves your resources. And that gets you around some of the issues with performance and scale. And so in general, one of these two approaches will work for you. And CRDs are easy to implement. Aggregated API servers, probably better for large numbers of resources and performance. So we decided to go ahead and do this as a controller CRD. This is pretty much the most common model for this. So what would you do? You create your CRD, all your custom resources are stored in the Kubernetes API server. And they're stored in etcd and etc. And the controller is just running there. It runs in a controller loop and a reconcile loop. It watches resources and then it tries to do things based on the changes in resources. So great things about this: persistence, Kubernetes. Storage of your resources, Kubernetes. It's the same thing actually, but API endpoints, Kubernetes handling those for you. Security, well, securities we're going to get in either case. Again, your client and application are fully disconnected. If this controller goes down for a few seconds, we probably will never notice. I mean, it's taken us 1.4 seconds just to get a round trip on the resource. So if your controller's down for a few seconds, you probably won't notice. There's a lot of stuff available to help you. There's like the operator SDK to build out this controller. Now the cons of this are, so say for example you have a large number of resources outside of Kubernetes that you want to represent in Kubernetes. Now you've got to sync, and especially if those are modifiable outside the system. Now you've got to be syncing these things into Kubernetes, and that gets kind of painful. Performance, as we noted, the whole write to etcd, controller wake up, okay, kind of kills you there. Let's see if we can move this along. So an aggregated API server, this is one where your aggregated API server actually handles the resources for you. So it implements a API endpoint. You give that to the API server. Whenever a call comes in, whenever a REST call comes in, Kubernetes delegates that out to the aggregated API server. And that's a lot harder to implement, but you're going to get better performance in some cases. You can spew resources out and so forth through there. But on the other hand, you've got to do all of the work. So again, your pros, you didn't store the resources in etcd. If you have things that you just want to expose into Kubernetes as records, resources, you don't have to sync. Right? When you do like a list or a get, it can go directly to the backend system. And if you're executing operations here, the controller doesn't need to be notified. It can just have some hooks internally. Bad things, it's a lot harder to implement. You've now connected your client and server a lot more closely. If the aggregated API server goes down, those resources are not going to get served. You can't make modifications to them. You've got a dispatch problem and all of your persistence. The pro is it's not in etcd. The con is it's not in etcd. You've got to handle that. Okay, so a quick look at a possible example application where we're doing a CI/CD pipeline. We have 3 resources: pipeline, build, and deployment. So the pipeline resource would define a pipeline. That is, watch a Git repo, watch for these tags, look for new commits here. When those happen, build them. And the way it builds them is it goes ahead and creates a build resource, and it goes ahead and creates a deployment resource. So the pipeline is responsible for watching for things and telling the rest of the system to build and deploy. So that's all it needs to do. It just watches Git and it watches Kubernetes. Then you can have a build controller. It's watching build resources, and when it sees a build object, it can look in the, in this case we're building Docker artifacts. It can look in Docker and go, huh, do I have artifacts that match this build? Yes or no? No? Okay, well I'll go ahead and build that. It can go ahead, do git pull, build, test, and push that out to the registry. Then we've got the deployment controller, and this can also be watching, so it's watching for the builds, and it's saying, okay, here's a build that I haven't deployed. I'm supposed to deploy this thing. It's watching the deployment objects, really. It can say, okay, I need to deploy this build. When that build is ready, I'll deploy it. So that lets your flow be the user creates a pipeline resource. The pipeline controller is watching Git and generating build and deploy resources. The build controller is watching build, doing builds and creating artifacts. And the deployment controller is watching deployments and deploying things for builds. You have 3 separate resources. Now, one of the neat things about this is that everything's fully disconnected. And you can, for example, simply create a build resource that didn't come out of a pipeline. And that can trigger the build controller to go off and do things. You can trigger a deployment resource that you can build, you create a deployment resource that doesn't have anything to do with the pipeline. It needs to have a build. So, one thing to look at there. All right, I'm in the home stretch here. So now that you've built your application, data protection may come into play here. So if you have state in custom resources, you may need to protect them. So you really have to look at what will happen if I lose all of my custom resources. And if you do, are you going to be in trouble? So anything that's unique in Kubernetes and important to the running of your app probably needs to be backed up somewhere. So one of the things we would ask is, like on restore, it's basically a cold start, so you have to be able to handle that. Restore ordering and stuff you need to think about and maybe expose to the backup application. Pausing reconciliation is kind of nice, having an option to pause reconciliation on a server. Really advanced applications can have backup and restore APIs. And doing your owner refs correctly so that we know which resources that belong to your application is good. And I believe, okay, so conclusions. Right now, mostly used for Kubernetes resources and system utilities. I think these are the conditions that if you're considering building this for an application, you'd want to look at this. Is your dependency on Kubernetes acceptable? Is client access to Kubernetes acceptable? Can you fit your operations into the declarative model? You don't have to, but it's kind of nicer. Relatively low volume of operations, large units of work per resource update. And your total number of resources represented should be, relatively small. Okay.
We have space. Oh, we're out of space. Burning questions. All right. Well, one, Ben.
Can you apply RBAC to API server objects?
I believe so.
Can you repeat the question?
Yeah, so can you apply the RBAC controls to aggregated API objects? I believe so. I believe that the API server is going to do that for you. But yeah, so that's a plus that you get, but.
Awesome. Well, big hand for Dave, and thank you.
Thank you all for coming.
stretch. We've got 2 more 30-minute talks. Then we've got a bunch of lightning talks, which will close out our day for us, which is great fun. And up next is detecting cryptocurrency mining with eBPF. We've learned a little bit about eBPF today. We'll continue to learn more. And quick aside, there's an eBPF pre-game event tomorrow at the main facility. If you haven't signed up for it, you may still be able to. That one I don't know for sure, but feel free to try. And with that, I would like to introduce Tracy Holmes, our next speaker. So give a round of applause to Tracy.
Hi. All of my favorite people are in the front row, and they're making me even more nervous while being supportive. I have emotional support talk people. You may see Duffy come up front with a Rubik's Cube. You may see Laura dance across the front of the stage. And with Marino, we never know what'll happen. So that's where we're at. But if you are in room 1, and hello everyone out there, this is Detecting Cryptocurrency Mining with eBPF. I am Tracy B. Holmes. I am a technical community advocate at Isovalent. And you've probably heard of us, so I'll just leave it at that. All right, let's see if the pointer works, because it's a Logitech. Hey, all right. All right, so you see a little cute little bee up there? That's Tetra bee, and that's literally how I found out about Tetragon. I like the logo. Isn't that horrible? So it started with Tetra bee. I had just started. I've only been at Isovalent a few months, and so I was trying to find something that I could start learning about that was interesting to me. And I've always been interested in like security, compliance, policies, that kind of thing. I don't like people coming in my house that shouldn't be in my house. That translates to the tech that I like to work with. And so at the time, Tetragon was like literally newly open source as of 1 month before I started. I was able to have Natalia come on our Echo live stream, which is eBPF and office hours. You can get Echo out of that some kind of way, just work with me. But this is what I call a discovery talk. So discovery talks are how I make my addled brain learn things. I force myself to learn things because I have to, present them to you. I won't let you all down. I'll typically let me down instead. So this was the thing that I wanted to learn about. So this is going to be full-on notes so I don't get this wrong and none of our engineers get me. All right, here we go. So Tetragon, of course, is an agent. It can run on top of any Linux system. And in case of Kubernetes, it's cloud environment. It's a daemon set. If it's your bare metal VMs or whatever, that's a container that can mount certain configuration files as volumes. It also uses eBPF to extract security observability data, and it'll give you runtime enforcement. I'm also going to try to get my Apple Pencil out because, of course, my iPad decided to not let me scroll my notes. So let's see. All right, here we go. Ah, that worked. All right, so there are a lot of layers, all of these nice little blocks, where Tetragon can extract data from, and it'll provide enforcement. So if you start from the low level, you get data access, file access, and the file access network with a variety of parsers, including the level 7 parsers. You also get namespacing or namespace technology in the kernel. It can be like network, PID, mount, UTC, whatever. But you also get capabilities and privileged access. Then you also have the process execution layer, and that's where we get all of our Syscall and any kernel function activity. All right, I'm in this pencil. I think this is my safety pencil. All right, also, very important, Tetragon is transparent. It doesn't require any application or code change, but it's also part of the Cilium family, but it doesn't actually need Cilium in order to run. Remember that. It's going to be important later. But also, eBPF in real time. So, can you all hear me? I think I just screwed up the mic. Here we go. All right. There we go. It wasn't behind my ear, it was behind my lock. There we go. Tetragon's runtime security enforcement observability tool. I like observability. It means I'm nosy. But this means that Tetragon applies policy and filtering directly to eBPF in the kernel. If you're talking about flexibility, Tetragon will hook into any function in a Linux kernel, and it'll filter on its arguments, return value, associated metadata. Pretty much, if you want to know if it's going on, you can pretty much use Tetragon to find it. But it also allows hooking deep into the kernel, and that's where all the data structures and stuff cannot be well, you want it to hook into the kernel so the data structure and stuff cannot be manipulated by users and such. So, if you want to know what activity we care about, this lists some of the stuff that we need to monitor. So any malicious activity that matters, it does at least probably one of these things. And all of these activities can be correspondent to an event that Tetragon generates. That's a nice little list, but that's what you're probably wanting to be nosy about, that you noticed was running in the background that you didn't realize was running in the background, which is kind of where this talk came from, but we'll get back to that again later also. How can you spot it? This is how this can be done, and it's been done a variety of ways in the past. So while we're talking about this, I'll give you a few more slides on like how it used to be done and kind of how we're doing it. That list includes trace, seccomp, LSM, and of course, eBPF. See? All right, Mike guy, we're going to talk about people with long hair next time. I got you. It wasn't behind my ear. I got it that time, yeah. I'm going to put on my glasses. Can you all hear me better now? Yes. All right, awesome. This is better. I had no voice at all last week. Progress. All right, so this is the oldest approach. We're at LD preload. So the oldest approach, you would be able to load a library into an app without awareness or changing that application. And we can essentially inject that library into the application and watch all of the system calls that the application is performing with that library instead of the kernel. So this is called system call proxy or LD preload proxy. And that's great, but it can be bypassed. If the application is statistically, I said that wrong. If the application is statically, there we go. Liz is like, not the right one. Linked, then the LD preload will have no effect, and we lose all kinds of visibility, as well as any enforcement. And that means it'll be ineffective. And it's kind of abandoned from that perspective. Now, syscall checks within the kernel. We can do system call checks or syscall checks when we enter or exit from a syscall at the kernel level. There are well-defined points in the kernel for tracing the entry to and exit from syscall. You can hook into these with ptrace. I mentioned that earlier. Seccomp profiles, mentioned that earlier. They get evaluated here, and you can hook into these points with trace points or kprobes to run eBPF programs. So much better than LD preload because the application can't be bypassed as easily, but it's still vulnerable. So this is vulnerable, and Duffy's going to laugh at me because we just talked about this, to so-called top 2 attacks, which are time of check or time of use, or in Duffy's case, time of first use. And if you want to know why I'm saying that, he will give you a very great example and how you're sneaking into a refrigerator before I tell you that you're not supposed to be in the refrigerator. Talk to him about that. The hook point when the solution sees the system call is before the last moment, and that's when the application can change it. So you can see it in the picture. Hook point is at the syscall entry level, and then the syscall handling copies those syscall parameters into the kernel from user space is after the checks. So it is possible that an application shows parameters, innocent file name, that thing you didn't know that was in there. I'd like to open that file. The kernel copies those parameters from the user space, but it's possible for an application to still change it to something else after the checks. Hence, he got into the refrigerator before I told him he couldn't. He stole an apple juice and he was gone. Bad Duffy. So we need to make the check at the right place. To avoid being vulnerable to these, I just like saying that, issues, we need to make the checks later after the kernel copied the parameters at the right place. People on camera, I am looking at these notes because I am known to get my words twisted up, and someone will tweet that I told you that you could do something with Tetragon that you could not. All right, back to my speaker notes. Linux security modules. In fact, there's a well-defined interface for doing this, and that's the LSM API, or Linux security modules. It's relatively old. It allows you to do security checks and enforcement at the right level. Stable, safe place to make checks. Requires additional kernel modules to load, and the infrastructure doesn't always allow that, and it's very static. This is used by AppArmor and SE Linux to check syscalls against profiles of what behaviors are allowed. For example, which files can be accessed by which programs. BPF LSM. This is better known and better suited. It uses eBPF to make LSM dynamic and is a step forward, and it's almost what we want. These API calls are all in the right place, and it's designed to be high performant. You get access to the kernel data structures, and they're already pre-populated with useful info that you might need for your security check. But, and here's the but, you need a modern kernel. BPF LSM was only introduced in 5.7, and most of us are not using kernels anywhere that new in production. Most of us, I didn't say all of us, most of us. And you're limited to the hook points that LSM provides. I actually have a link to this in this slide that I probably need to add to my resource slide that I'll add before I give you all access to the slides. But if you need new hook points, you gotta change the kernel code. And this is where TetraB, my little B dude, comes into play. So we want the same property in terms of safety, hook points, and security than BPF LSM, but we want to avoid the kernel requirements, any additional hook points that can't be found in LSM. We use kprobe and trace points to hook into that kernel function. At this point, I've heard kprobe so much, I need a tattoo that says kprobe. I have a shared state between BPF programs with BPF maps, and this is the yellow database that you see on the picture. This allows multiple eBPF programs to work together, and it also allows kernel filtering, and that's the base of the high performance that you get. Context is everything. I like these diagrams, it has emojis. First of all, context is everything in terms of security, and we need to understand and have as much, if not more, data than possible. The better and more fine-grained the context, so in this case, security observability events that we mentioned, the easier it is for a security team to understand the log files, create queries, and do alerting. It's also easy to figure out what's the cause and what's affected. The little apple juice gremlins. And this is a slide I threw in to give you an idea of what things look like. Pictures? None? All right, we're going forward. So if we look at the networking sides of things, and also this, you're going to get some of your time back, even though I went over. This is very short. So these are all the events when a network connection happens. We can observe everything starting from DNS, TCP, HTTPS, TLS, and if we go from the top to the bottom, if you could actually see all of those lines, you see that the process started with curl, and it was invoked with the argument of cilium.io. And you can see that in the DNS resolution. I promise you it will be better on the slides I give you all. In this case, we made the request from a Kubernetes pod, so it'll try to resolve a bunch of the Kubernetes services. And in the end, you actually resolve cilium.io, and you see the IP return. If you want to get more into like finding out where stuff is coming from, try the capture the flag that we did a few months ago and try to interject Tetragon into it and see what happens. You'll find lots of nice little stuff in there. And this is what it looks like if you're preventing sensitive file access. Now, here's where, if you've ever gone to one of my talks, Marino, don't tweet this because I know you will. If you've ever gone to one of my talks, you'll know my discovery talks I have attempts. They're very good attempts. Let me tell you what happened this time. When I'm at home, I work on WSL most of the time. If you all saw me downstairs, what was I working on? An M1 Mac. Tetragon didn't like that. So if you saw me downstairs, that's what I've been frantically working on, trying to make it work. And it took Duffy to come over and go, pull this up. And we finally traced it back to it. The image is part of the issue, and ARM support is just not there. That being said, what I will do for you all, in addition to this, because I really do want to make sure I figure this out, in addition to trying to get this to work on M1 some kind of way, even if I have to work with the engineers to get it working, oh Lord, that's a commitment that's on camera now. The other thing I want to do is actually do a full live stream, probably towards the end of November, where if I can get Duffy, like if I bribe him with apple juice, we'll go on stream and like break down what it looks like. The premise is the same. Tetragon is going to help you. Little B dude's going to go through and block crap that you don't want going in there and help you find stuff and help you enforce crap. Adding the cryptocurrency bit was the bite. Natalia, who is not here because I was going to point her out, is really good with coming up with ideas around Tetragon, and this one caught my eye because honestly, I honestly don't really know how miners work that well. I just know that they usually steal the resources that I want for myself. So hopefully you'll see Duffy and I before the end of the month get in and just break. That's an agreement from Duffy, by the way. But here are the resources that I used. Natalia, my colleague, that helped me come up with this idea. We did an Echo news about 2 or 3-ish months ago that has a full demo of Tetragon, so you all can see how it works, because I don't think a lot of people actually know how Tetragon like natively works. So if you want to check us out, that live stream that Duffy and I will do will be on there. If you want to get started playing around with Tetragon on like an Intel, go for it. That's where you will get your Tetragon set up. And the Pixie blog post, Pixie people are so nice, that I was going to use for the miner. They have a really nice write-up on a Monero miner that I was going to actually use for this. And so that's what hopefully you'll probably see whenever we get to do the live stream. So that being said, I appreciate you all. If you haven't gotten either of these books, please go get those. They're very interesting reading. The reports are, especially the security observability one. Also, got you. You can get up here and say it if you want to. The security observability with eBPF one is the same colleague that I just mentioned. She was co-author of that particular report. It's very interesting. You learn a lot from it. I think it's in my bag in the room, to be completely honest. Liz's book is What is eBPF? If you want to know what eBPF is, that's going to be it. And if you all are going to be around KubeCon, I think you can download, is it 4? Oh, so tomorrow for Cloud Native eBPF Day, I believe we have 4 additional chapters to download for that particular book, which I need to do myself. Don't think that I get everything free, to learn more about what I've been trying to talk to you all about. So while you all didn't get a demo, you get a promise from a live stream from me. You all hold me to it. Marina, you can tweet that one, because I know you'll hold me to it. And thank you all so much for joining me in my Discovery Talk.
After the break, but please help me welcome Sanjay from OpenSUSE or SUSE in general. Talking next. Take it away, Sanjay.
Thank you. Hi, everyone. My name is Sanjay Nadavajala. I'm the engineering manager of a project named Opney over at SUSE. I was part of Rancher Labs. We got acquired. Opney is a multi-cluster observability and AI ops project. And so let me give some backstory on how we started and how we got to where we are today. So I started Opney off about a year and a half ago as an AI ops tool. The goal was to ingest logs and provide AI insights on these logs, basically highlight what are suspicious and anomalous logs inside of your Kubernetes clusters. So it was pretty neat. It was able to infer off of your control plane logs, which came through pre-trained models that we trained ourselves on the Kubernetes control plane. And it was also able to learn on your workload logs and generate models by itself and self-update so that these AI models adapt as you change, remove, or update your workloads. So we built this out and we started showing it to people, and people started saying, we already have our own logging system. Can you build a connector for us so that way we can leverage your AI models? And then we were like, actually, we're kind of like building a logging backend under the hood. Why don't you just, you don't need a connector. All you need to do is be able to set up Opney inside of your Kubernetes cluster. And similar to how Prometheus, you just install Prometheus into your cluster, and then you enable Grafana, and then you're able to look at your metrics. Opney, similarly, is you install it into your Kubernetes cluster, and you're able to generate these, consume these generated AI insights. And people were like, we already have our own logging system, and we were already going halfway there by putting a logging backend there to begin with. So then they started asking, can you fully develop that logging backend and let us use it for more than just AI insights? So that's when the project transformed from just an AI ops project to a observability project. Then they started asking, can I send multiple clusters logs to your backend? So that's when we decided to make a multi-cluster observability project that comes with AI ops, and it's not only for logs anymore, it's for logs, metrics, traces, and so that's what I'm going to be talking about today. There we go. All right, so observability, there's 3 pillars of observability. Those are logs, metrics, and traces. Observability data allows operators to understand what's going on in their clusters or their systems. And I'm sure all of you know what logs, metrics, and traces are. Traces include network logs, and all of these things require different agents to run to be able to collect that individual data type. And you also need some place to send this data. So these places, these systems that can store and analyze these data, we call observability backends. And many people probably rely on SaaSes. Like, out of you all, how many of you use something like Datadog or Prometheus? But just by a show of hands, like Datadog, okay, Prometheus. So we've actually seen that overlap. Like, people like to use both Datadog and Prometheus because Prometheus, 1, is open source. 2, people are just very familiar with it. And 3, you kind of control your own costs. So there's like a cost objective there too. Anyway, a full-fledged observability system consists of both agents and backends. Let's talk about observability agents. So what we have over here is the CNCF landscape for observability and analysis. At the top over here, we have monitoring. This section right here is for logging, and the bottom section is for tracing. So the top section for monitoring, most of you use Prometheus, it looks like, and also majority of the crowd is using Datadog. So typically for something like Datadog, you install an agent into your clusters, and that agent knows exactly what endpoint to send your monitoring data to. So it's able to do this. Similarly, Prometheus, when you install it, you typically install it within a cluster, and it self-observes that cluster. It picks up, it scrapes any Prometheus endpoints that exist within that cluster. For logging, most of you probably use, actually, I don't know what you guys use. A lot of people that I've spoken to like to use Splunk. Some people like to use Datadog. A lot of people like to use the hosted Elasticsearch OpenSearch now on AWS. And some people like to set up their own Elasticsearch stack or their own OpenSearch stack. OpenSearch is just the hard fork of the last Apache Elastic. LogDNA is pretty nice too. So like there's a whole bunch of different logging tools available. And for almost all of them, a lot of people like to use FluentD because it can send to multiple downstream logging backends. Grafana also has Loki, which works really nice with Grafana. Loki is like their logging backend. And then for tracing, the most talked about one is OpenTelemetry. It has a lot of promise. It's the second most worked on project, I believe, in the CNCF landscape. So there's a lot of work being done there. But OpenTelemetry requires developers to enable traces and inject their modules with OpenTelemetry for it to be able to work, whether it's auto-discover mode or if they natively use OpenTelemetry to capture their traces. My point with all of this, actually before that, let's go to the okay, there we go. Observability backend. So observability backend store observability data and allow users to explore and query it. So there's backends, agents, front ends. The entire landscape is composed of projects that are different components of a observability stack. No one project really allows you to do everything all in one, and any project that does is usually behind a paywall, and it's a SaaS. It's part of the reason why companies like Datadog or Dynatrace or Splunk, they charge so much because they make everything easy. If you were to go the open source route, all the components are there. All of them are open source projects, but it is up to you as the user to set this up yourself, which is challenging. Okay, so that's where Opney comes in, and I put a picture of an iceberg over here because I like to look at observability as an iceberg. Everything that you see in your logging, monitoring, and tracing systems is pretty much everything above the surface. You go to check it, to check the health and status of your clusters, your workloads, and you're not really taking a look at what's going on underneath the surface because no one really has the time to when you're managing a lot of different clusters, especially when observability data, it likes to emit a ton of data. So like, say for like logs, typically no one looks at logs as a preemptive tool because let's say you have 1 million logs, you don't know what to look at. People like to use metrics as a preemptive tool because you have nice graphs that are fancy and nice to look at, and you can set like alerting thresholds for them. But it's really hard to use all of these, like correlate all of these tools together because they're all so disjoint. So logging, monitoring, tracing. And so I like to say that Opney allows you to see both above and beneath the surface to identify like what's actually going on in your clusters. So Opney is completely open source. Again, we're coming from SUSE Rancher, so like all of our projects are open source. It's very easy to install, and you guys will probably get an idea of how that looks, or I highly encourage after this to go check it out yourself. It's easy to create and manage observability backends and agents. So when I say easy, it's literally just configuration that you can set up through a UI, click of a button, and everything's installed for you. And this is in the multi-cluster fashion, so you guys will get a an idea of what that looks like soon. It's multi-cluster and multi-tenant, so you can actually save a lot of compute and compute memory and networking costs. Instead of, let's say you have 10 clusters, instead of setting up 10 different Prometheuses and 10 different Grafanas for each of these clusters, you can have one Opney cluster send all of your data to this Opney cluster, and you get to manage it yourself, so you're able to manage both the clusters in terms of compute and hardware, as well as costs. Which is something that it's hard to do if you don't have Opney. It comes with AI ops included, so in a later slide you'll see like what are the different AI ops elements that we're working on. It's Kubernetes first, and lastly, I do work for SUSE Rancher, so there is a Rancher integration. It's even easier to use it if you're using Rancher. Observability without Opney. This image shows your containers hitting the bottom of the iceberg and crashing. But it's expensive if it's a SaaS. The nice thing about SaaSes are like they're very easy to use, they're reliable, and you as a user don't need to manage anything. But inherently, you all are at a cloud computing conference, so like all of you guys like to manage stuff, and so the idea of moving away from SaaSes, or at least moving away your non-essential workloads away from a Datadog or a Splunk, can make sense for you, as it does for some of our users. It's difficult to set up if it's open source, so I showed you guys the CNCF landscape. There's hundreds of tools and projects out there, and there are many different permutations that you can use to set up your logging, monitoring, and tracing stack. And so since you have so many different options, it's actually very hard to get started. And it's difficult to create and manage these observability backends, because if something goes wrong, then you have to look at what tool went wrong, and tools are kind of disjoint, and they don't work together nicely. And AIOps is difficult. My background's in AI, and I can tell you that most of the AIOps tools out there that claim to do root cause detection and like self-remediation, they're very primitive, and like point blank, most of them don't do what they claim to do. Especially because AIOps tools are typically connected to your observability backends, and they don't actually manage the infrastructure. So like self-remediation is very difficult to do, and that's kind of why we started this project at Rancher, because Rancher helps manage your infrastructure. And with a project like Opney, if Opney is able to tell Rancher that like a node has gone wrong because it's run out of memory, then Rancher can auto-provision a new node for you, so that way you have more compute or memory, whatever hardware requirements you want. So that's kind of where the angle that we're attacking this entire space from. Opney's observability backends, we have 2 right now. Under Opney logging, we extend OpenSearch to make it easy to visualize and analyze logs, traces, and Kubernetes events. So one thing about Kubernetes events is that they don't persist inside of your Kubernetes cluster. So let's say something goes wrong with your Kubernetes cluster, and it's inaccessible. You can't really work back like why it became inaccessible or why it went down. And so one of the biggest things that we saw immediately once we started developing this is that we need a backend that also persists Kubernetes events. So Opney does that for you. You can send OpenTelemetry logs to the Opney agent, which we'll talk about in just a moment. And if you ship OpenTelemetry logs to the Opney agent, it will automatically tag it as per like what cluster it's associated with, and then send it to the Opney backend. It includes Kubernetes native RBAC configuration, and everything's Kubernetes native, so like it's highly configurable, and you can size it and modify it as per your needs. To enable Opney logging, you will go to the UI, and we'll walk through that at the very end, but in your downstream clusters, it's actually very easy to turn on and off logging, because one of the challenges with any sort of observability stack is you need to, let's say clusters become important to you because you start running some workload on it, and then you stop your workload. Maybe you don't want to run Opney or Datadog or any observability stack on it while these workloads aren't running. And so Opney actually makes it very easy for you to turn on and off logging in your downstream clusters that you have the agent installed into. So we'll see that soon too. Opney monitoring extends Cortex. So Cortex is actually a project that was created by Grafana. They were using Cortex as part of their hosted Grafana before they switched to another project called Mimir. But anyway, we extended Cortex to allow for multi-cluster long-term storage. So Cortex already allows you to do multi-tenancy, but multi-cluster is not baked in. So we extended Cortex to allow for that. It's a long-term storage for Prometheus metrics, and yeah, it provides an API that sits in front of Cortex, provides RBAC, and using the Opney admin UI, you can easily provision like multi-tenancy and manage users, and we'll see that too. To enable monitoring in your clusters, it's the same as logging. It's with the click of a button, and you can turn on logs and metrics from your downstream clusters. So the usage of Opney agent. So let's say you were to use Opney. The recommended approach is a multi-cluster fashion. Of course, you can do a single cluster approach as well and install So I'll describe the single cluster and then we'll move to the multi-cluster, which is what's on the screen right now. So in single cluster, you have your workloads running, and let's say you want to experience similar to what Prometheus gives you. You can install Opney, enable logging and monitoring within that cluster, and it will auto-observe the cluster that it's installed into. Now, let's say you want multi-cluster. You set up Opney, and you expose its services to the outside world, either through a load balancer, ingress controller, however you want to, and open it up to the outside world. And then you would install Opney agents into your downstream clusters, and then tell the agents in your Helm installation, or you can install it through the Rancher UI, tell it where the upstream Opney sits, and it will start shipping over logs, metrics, or traces, depending on how you configure the agent. And all of this is done through a UI minus the agent installation. So once the agent is installed, it starts speaking to the Opney gateway, and within the Opney admin UI, that's when you tell a downstream cluster to start shipping over logs, metrics, or traces. So yeah, go ahead.
Can you also have the upstream of the dashboard onto the agent where I'm installing? Like, let's assume I want to install this only on one cluster. Like, I don't have multiple clusters.
Yeah.
Then can I have this upstream, whatever the component and the dashboard and the agent on the same cluster?
Yeah. Just to repeat that question. So the question is, let's say you have an upstream Opney cluster, and you want the dashboard to exist only there because like you have no downstream clusters. This is basically a single cluster mode that I was just describing. So a single cluster mode can auto-observe the cluster. Let's say your workloads are running within the upstream Opney cluster. That would be the use case. Like you would come with the dashboards, and you would just enable it into the local cluster. Okay, so the Opney upstream architecture. So we used a bunch of the open source projects that was in the CNCF landscape, and we configured it all so that way you don't need to. These are all of the different elements that you as a user would have to configure yourself if you were setting up your own HA observability stack. And so I'm not going to get into this right now. This is also on our website, so you can go check it out and just ping us on Slack or create a GitHub issue if you have any questions. But the point with this slide really is observability stacks are hard to set up by yourself, and Opney really makes it easy. Go ahead.
So in the previous slide, so you have a Helm chart.
Yeah.
I just take this Helm chart and install it in my cluster, job that.
Yeah.
Because previously, like, it has been a huge struggle for me to set up multiple Prometheus and Thanos, Cortex.
Yeah. Right. Correct. Yeah. So the Helm chart installation installs Opney, which is bare bones. When you install Opney, it comes with a gateway as well as the admin UI. So you go to the admin UI, and then you would enable your backends. So you would enable your monitoring backend. So it's actually even easier than configuring everything via like your Helm values. Mhm.
assume I already have lots of Prometheus in my company.
Yeah.
Configure it, manage, and I don't want to change it.
Yep.
Then can also Opney go to the existing Prometheus and gather, or should they have?
So as long as it meets the question is, if you already have Prometheus running in some of your downstream clusters, can you use those existing Prometheus instances to ship those metrics over to an upstream Opney? The answer is yes. If you're using a specific Prometheus version, that version is, we detailed it in our website. You can use remote write to export those metrics out. The Opney agent architecture is a little bit more simple. So we actually install Prometheus in agent mode and remote write it to our Opney agent. Opney agent writes it to our gateway, which is not pictured here. That's for metrics. For logs, we install Rancher logging, which is actually just FluentD, operated by the Bonsai Cloud logging operator. Then we ship it, we send those logs over to a Opney shipper, and that Opney shipper takes care of both logs and traces and ships that over to OpenSearch, which is our logging backend. Okay, so the Opney admin UI. So once you install Opney, you would navigate over to this page, and on this left-hand side, you see a couple different things. So you see your clusters. These are all your downstream clusters that are registered to your upstream Opney instance. So in this example, we have 3 downstream clusters, and we have the local cluster as well. These buttons right here. So if the downstream agent signals to us that it's in a ready state, that means it's connected to upstream Opney, and you can click these buttons to install monitoring or logging in your downstream agents. And it's literally just a click of a button, and if you hit that, then it will install the logging capabilities in the downstream agent and start shipping that up to upstream Opney. And you can turn on and off these capabilities however you like. You can manage your backends over here. So there's a logging monitoring backends. You can configure your logging clusters however you like. Let's say you have a ton of different clusters, downstream clusters that you're going to send logs from. You can increase your ingest nodes for OpenSearch quite easily. And so you can scale down, up or down your logging clusters or your monitoring clusters very easily using our UI. Lastly, I haven't talked too much about this yet, but we did introduce SLO capability as part of our Opney alerting stack. So you guys will, right now we're on v0.6, which we just released this past week. For 0.6.1, we're going to have a UI for alerting backends too, so you can configure Slack or email or other alert manager backends easily through our UI and set up SLOs, so that way if SLOs are breached, then you'll get an alert in your configured alerting backend. I'm going to talk a little bit about the AI ops. Just let me quickly do a time check. So we have a few more minutes left. So Opney AI ops, this is how the project actually first started. So we really focused on log anomaly detection initially because if you go to any of the forecasting libraries or anomaly detection libraries that are out there today, almost all of them focus on metrics. They're all numerical based, and nearly none of them are textual based. And pretty much none of the open source libraries that are out there are good for log anomaly detection. In fact, I think we must be one of the first that is out there for log anomaly detection. So we really focused on that because we found that in practice, metric anomaly detection doesn't work. Kubernetes clusters, by nature, you deploy workloads onto them and then you remove workloads. So there is no predictability per se unless you're running one workload all the time, and that's the only workload that you're running. If that's not your use case, metric anomaly detection will not work, and we found it that's the case. So we focused a lot on log anomaly detection. So for log anomaly detection, we pre-trained a couple different models. We pre-trained a couple models for the control plane, Rancher, like the Rancher system itself, as well as Longhorn. We previously had a capability where it can self-learn your own workload logs. We're reintroducing that capability in our next release as part of 6.1. If you have a GPU, you can leverage this self-training mode that Opney provides. The other pre-trained models that we have, they're all deep learning models, but we've optimized it such that it can run on your CPUs just as efficiently. And this is due to the fact that logs repeat a lot in nature. So logs, we boiled it, let's say you have 1 million logs, we boiled that down to like say 100 or 1,000 log templates, and we actually make our inferences based off that. So we've made a ton of efficiency improvements and kind of tricks to have this deep learning model, which typically runs on a GPU, to be able to run on a CPU just fine. So that's where Opney AIOps currently is. What we're working on behind the scenes is we previously also had a metric anomaly model. I know I just bashed metric anomaly a lot right now, but we developed that because it's something that like a lot of users like to see, because metric anomaly forecasting is nice to look at in a GUI, because like you see like upper bound thresholds and lower bound thresholds, and it looks like the AI is actually doing something. So we have that implemented into our system, but when we reintroduce it in a future release, probably before the end of the year, we're not going to include it as part of Opney monitoring. We're going to integrate it into Opney alerting. And so the reason for this is when the users set SLOs up, and we'll talk about SLOs, I hope. I'm not sure if all of you know what SLOs are, but when a user sets up an SLO, the metrics that are associated to the service level objective are important to the user, and our metric anomaly models will only run on those metrics, not all of the metrics that they were previously running on. And then tracing, we have a root cause detection solution in the system. It's still, we're running through it and smoothing some things out. So we are going to introduce a root cause detection module in the future if you have tracing capability enabled. Oh no, give me 1 second. Okay. Opney alerting and SLOs. Since we're running very, very low on time, I'm going to quickly run through this. So Opney alerting is going to allow you to create and manage alerting backends and SLOs quite easily. There's tools that are specifically meant for this, just like the other parts of the observability stack. So we're going to make it easy, like we're going to slap a UI on top of Alert Manager for you to easily configure your alerting backends. This will integrate with all logs, metrics, and traces, and work very smoothly with the rest of the Opney system, so that way you can set up thresholds on your observability data, as well as the Opney AI insights that are generated. And so with that, let me show you guys what Opney actually looks like. Okay, so this is what the Opney admin UI looks like. Currently, I have the local cluster, which is what upstream Opney is installed into, and I have 3 downstream clusters. These 3 downstream clusters all have the logging capability installed into it, and all 3 of them are RKE1 clusters, Rancher's Kubernetes engine. The upstream Opney that I have this installed into is an EKS cluster, and I will show you what the logging backend looks like. So this is where I set up the logging backend. This is where I'm externalizing this backend. I have created 3 control plane nodes, 3 data nodes, and 3 ingest nodes. They actually just run as pods, and then you can turn on for the control plane. This is all related to OpenSearch, so you can configure your OpenSearch cluster in any way you want, easily through this UI, and then enable the Opney dashboard, Opney logging dashboard. So let me show you what the logging dashboard looks like. So this URL is actually live right now. If you guys want, you can go and check it out yourself on your cell phone or computer. The login password is admin. So this is the discover page for logging. And so if as an operator, if you come to this page and you look at your logs, you don't really know what's going on with your clusters, which is why we created the Opney AI Insights dashboard here as well. So if you navigate over to the Opney tab, you'll see the Insights dashboard, and I'll let it load up. And I actually injected a failure into each of the 3 clusters. As a user, if you were to look at your clusters, these are the 3 right here. They all say that they're inactive and there's nothing wrong with it. But actually what's going on behind the scenes is the kubelet is freaking out on each of the 3 clusters, and this is due to a memory leak that's going on in all 3 of the clusters. So our pre-trained models catch this and are able to alert you that like something's actually gone wrong. Your Prometheus metrics likely will not catch this, and we've run out of time, so I can't show you that dashboard today. But your logs, and it's unless you are manually looking through your logs, you won't be able to catch this. But with Opney, we'll catch it for you. So with that, I've run out of time, but I highly encourage you guys to join our global online meetup in 2 weeks, and we'll do a lot more deep dive into some of the different technologies that we have in Opney. Thanks.
Awesome. Thank you, Sanjay. Does anybody have any questions? I know we had a few taken during the talk. Super. Well, thank you, Sanjay.
Thank you.
We have a 10-minute break, and then the lightning talks will start at 5:40. So you have a few minutes, take a deep breath, and then we'll wrap up for the day with the lightning talks. First up, we got George.
Yeah, is there a timer? Can someone do like 3, 2, 1? Yeah, thank you. Okay, awesome. My name is George Castro. I've worked in the Kubernetes community in the past, and before that, I worked on Ubuntu, and I'm currently working in the cloud governance space on a project called Cloud Custodian. I also have to drive. Can I get a volunteer to like, Sonny, can you hook me up? All right. All right. So I've spent time in both cloud native and client Linux, which is weird. I've always thought it was very interesting that you can come here and see some of the most amazing, skilled Linux system administrators and DevOps and SREs, and you all have Macs, right? But I came from this old kind of Linux distro world, and we all like to make fun of Linux and things like that, as you have so clearly seen. Yes. And I was like, you know what? I want to meld the two things together. I want to bring some of the amazing values of the cloud native world that made me just fall in love with Kubernetes, but I want to take that and take everything that I've learned about building operating systems at Canonical. What if we could have the cloud native desktop? So what are you talking about? So I know a lot of you have Macs and you're like, but it's so amazing. Look at my M2, amazing machine, right? I go to my university and there are just shelves full of laptops. There's so much machinery out there, and I believe that I have come up with a prototype of what a future client could look like if we were to take the cloud native tenets that we've all been learning and bring those to the client. Because the problem with the Linux desktop is it doesn't solve a problem anybody has, right? I mean, it really is, right? So I believe that the way to save the Linux desktop is to destroy the Linux desktop and to just call it what we do when we think about cloud native things. It's just another edge device, right? The payload might be different, but we treat it like another edge device. So what did I do? There are two distributions that are leading the way in this. One is Fedora with Silverblue. The other one is OpenSUSE with MicroOS. And Endless OS, if you ever want to donate a laptop, you can put a thing on it and it has like educational content for kids. It's amazing. So I grabbed Silverblue, and Josh and I have been working in Kubernetes for a while. I was like, dude, what if we could like make it awesome, but also bring it to your desktop without a VM, right? Now, a lot of you are saying, I've seen this before, it looks a lot like WSL. One of the greatest things about WSL is it forces that separation between our user space, where we're doing the Linux cloud business, and our desktop, different layers. So let's bring that to a Linux desktop. The entire root file system on this laptop right here is read-only. It is image-based. I have auto updates on, maintenance, very, very minimal, right? We're not talking apt-get update, and then you added a PPA, and then you broke stuff, and then someone makes fun of you, and then someone tells you to install the other thing, and next thing you know, it's 3 in the morning, and you're like, as you can tell, I'm really trying to avoid buying a Mac. So I built this instead, in a way to kind of get the conversation going and think about how we're building stuff. So I'm going to give you a quick demo here. Did that come up? All right. This is my host terminal. It is, let's see, OS release. Can you all see that? That's Fedora, right? Because I installed Fedora on my laptop. However, what if I could use the power of the Linux container, the OCI container, and just use it as if it was something else? Now, I've rebooted, so the init has to happen because it's a container. What I have here is just a transparent running version of the Ubuntu Cloud image with all my home data. And, oh my God, I can't type. This is hard. Pressure. Time check. 1 minute, 5 seconds. Oh my God. All right, so I can't type, but the idea is, what if you could take any cloud image, any OCI image, and just be able to interact with it, and your data is there. And we separate that from the host operating system. Graphical applications that get installed with Flatpak instead. Totally different layer. You see a cool thing where you're like, saw a Hacker News, someone's rewriting a Vim fork in Rust or whatever, and I went to install it, and I couldn't find it in Ubuntu, and I couldn't find it in Fedora. What do you do? Well, you should be installing this Linux distro, and then you're arguing with a bunch of nerds for 25 minutes, right? Or I can hit this keystroke and just have an Alpine container instantly, and then I was able to install it, because that's where all the Rust nerds are hanging out, and I was able to get this cool, that you can't see because I can't type. I was able to get the thing that I wanted without reinstalling, but that protection of having my terminals and my user space. Think about being able to grab images from CI. Someone shows up to work, they get your customized little thing with all your development stuff on it. This is just the beginning. But we need to move somewhere, and I'm looking for volunteers to help me out to build it. Thank you very much. This is way harder than you said it was, Chris. Wherever you are, this is way harder than you said it was.
Awesome. Good job. Good job. Up next. Woo!
Well done, well done.
Good luck. It's tough.
I will be your microphone stand. Hold on. It's on the other side. Is this going to work? No? Yes? Maybe? Not yet. Not yet. Survey says? So, creating local cloud shouldn't be so hard. And at II, one of the things we've had a passion for is helping get all the beautiful things we create in our community and source code into someone's hands in a meaningful way that they'll actually pick up open source. Am I doing something funny? Open source. So we, back in the day, early on, before we started working with the CNCF, there was a piece of hardware called a pocket chip, or a Git chip, and you could actually flash it from the web. So we will take an entire OS and install it from a web browser. And what we did with the OS is we put up a provisioner where we booted some local hardware, and it, using Pixie and some other things, installed a Kubernetes cluster from the web, right? And on that cluster, we installed GitLab and the ability to edit stuff. What we're hoping we can do is this. If you look at what this project did, they had a piece of hardware where you could put a paperclip over a couple of connections and have it flash from the web. Now, I spent some time in Cambodia working with some local kids, and one of the things that they had access to was the cafes, but it was French versions of Windows, and their language wasn't native to that. So we worked and put some Ubuntu sticks together, and they were so excited to be able to read and write in their own language. They had these little, a button they could hit to make more sticks. And they said, well, how do we do this, hippie? I said, well, let's go to the local store, let's get one of those universe-changing sticks, and let's put it in there, and put down where they could read and write, and they could contribute just by using their desktop. And when they made more sticks, it was a copy of that. We worked early on before with Dell. They had a project called Sputnik, which was supposed to be the restore firmware for the XPS 13s, where you could put in a URL and it would deploy that particular laptop with Linux or with Windows and use chef recipes to bring all this together. And I just want doing all these things to talk about this is how we get hardware customized for someone and deliver this open source solution. Just recently, in the last bit, I found a project called Graphene OS, and Graphene OS allows you to go to a website and take your pixel and flash it. And that OS is built from open source. It's an ASOP image. But what I love about something we could do here with that i-style phone is that universe connector on the bottom, having a business in a box that somebody could create from any web page with that hardware. And when they go up to help someone, let's say their grandmother, they've got some computing, they don't know how to do tech stuff yet, but they turn on the phone and they say, is there anyone who could help me learn to do this? And on the phone, it boots up and connects them to someone that can help them. They said, that's the right device, let me help you. And you could connect the universal connector and remotely have a keyboard, have a mouse, have the things to even connect it to a phone and help them create this tech support. That's the initial point to get someone into open source, is to help them make a living at that point when they don't have any skills yet to deliver. But that phone itself, because it can do those network booting things, could actually deploy a local cloud in an isolated environment like on an island. So some of my target environments is working with, sorry, some of the indigenous people in New Zealand where there's a desire to be a part of the tech world with some sovereignty to be able to do it on their own. So I'm looking forward to taking the ideas of II, which is, II is two people standing next to each other. And if we could make getting into open source viral and easy and able to bring meaningful expressions of care to your neighborhood, we'll have a much more like Mr. Rogers, his neighborhood TV station was so
that program was so valuable that he helped to create the Corporation for Public Broadcasting and local stations all over the United States. What if we had local stations giving this, the programs that we have in open source as a meaningful expression of those neighborhoods run by the people in those neighborhoods? And so that's where you have an II service provider instead of an ISP that just connects us to Silicon Valley. Let's connect to everybody local and get into open source together in a meaningful way.
That was Hippie Hacker. Thank you. Good job. Up next, page is reloading. Do we have Karen? Good job. And so cubes and cubes. Chris, will you hold the microphone?
Someday. Let me see why my display is not displaying. Oh, okay. Just slow. Okay. Take off my mask. Go into slideshow.
Yeah, but you're going to have to mirror it.
Oh, thank you. Fortunately, I'm early. Where's my mirror? Oh, no, it's at the top.
Up there, yeah.
Okay.
At the top?
Oh, apply.
Yeah. There you go.
Okay. Let's close that. My slideshow starting. Go back. Okay. So, my talk is on cubes and cubes. I think we know first one is Kubernetes, hopefully. Second one is puzzle cubes. And I have props that are not very well organized. Shh. So here, has anyone solved, Rubik's Cube, speed cubes? Okay. Rubik's Cube is the original brand name. It has proliferated. The generic name these days is usually speed cube. There are all kinds of cubes. But this is the standard 3x3. This one, it doesn't have stickers. It's solid plastic, but it's the same thing. So you solve one of these cubes, you use algorithms, and they're called algorithms, and you pattern match, and then you have a set of moves that you memorize, and it moves pieces around into predictable places so that you can do another pattern match and use another algorithm and eventually, hopefully, solve your cube. We're going to call this one maybe, I don't know if there's not really a generic standard Kubernetes cluster, but this is pretty close. Let's just say you don't have any CRDs, you don't have anything, no super fancy controllers, you're just got a very simple, like maybe a K3S cluster or something running in a small environment. So here's our standard cube. So these are all actually the same. These are all 3-layer, 3x3x3. They just are different colors, different sizes. But they all, they move the same way, they solve the same way. So maybe you have a generic cluster, but you're running it in different cloud environments, or maybe, little things like that. Now, clusters come in different sizes. These are all cubes that are like this, except they get bigger. And I don't have bigger. Okay, this one is my magic N cube, but this is a 7x7 layer. The interesting thing about these cubes is that they solve basically the same way. You just need to learn a few extra algorithms, but once you can solve a 4-layer, you can solve a 5-layer, you can solve a 10-layer. They go up to commercially available 21 layers. I do not have a 21-layer cube. So, and these are here, there's in front, there's a 2x2, bigger 3x3, 6, 5x5, 6x6. So these are all cubes also. The interesting thing is, if I scramble them, they look like this. Some of them are no longer cubes. The thing is, these all solve like this. Few little differences, but it's basically like a Kubernetes cluster. You know, you have cubes that look clusters that look radically different, but at the bottom, you know, it's the same API endpoint. You might have a few CRDs, you might have some weird controllers running, but you talk to them the same way. You're using the same client. Everything is really similar. So these are basically the same. They're using the same core. The moves are very similar. You might need to know a couple extra tricks, but it's not. Once you know the basic solution, you can get most of the way there. Just like once you know basically how to run a Kubernetes cluster, you're just adding on to that. This is my cat sniffing. She's very helpful. So these are also, this is interesting. You have a standard cube. The thing next to it is also a cube. It's not a physical cube, but it solves, again, the same way. You use the same set of algorithms. You use the same way. So I don't know. We'll call that maybe an OpenShift cluster. So these are also cubes. However, these do not solve the same way. This one kind of rotates funny. You cannot use the same algorithm, so we will call this maybe OpenStack or something. Mesos. This is, again, this one's scrambled. So at some point, I thought, I really want to, I saw this kit online. Like, I could build my own cube. It's purple. I want a purple cube. They send this to me. It did not have instructions. So it's like a meta puzzle. It's how do I put this together? So it's like, I thought of it, it's like Kelsey Hightower's Kubernetes the hard way. So you can see the core here, it's partially assembled, and then the end cube, which works. It actually works. I actually did not have a picture of the stickers, but I have different shades of purple stickers. It's very pretty. So this is also a cube. This also solves the same way in theory. Oh, in theory, it solves the same way. I just got it on Friday. I have not had a chance to solve it. I spent about 30 minutes on it. My brain hurt. I will solve it someday, but it's like a cluster that somebody really over-configured. Maybe you've got Istio or something on there. I don't know. Thank you.
That's great. Thank you, Karen. Similarly, some assembly required. Jeremy, come to the stage.
Oh, one moment. What? As soon as it recognizes.
They gotta hear you They gotta hear you grumbling.
Oh, I can grumble too. I can burp more conies into this man.
Oh my God. That doesn't go to the microphone though. Thank goodness. All right. Okay. All right, so give it up for Jeremy.
Yeah, I know.
Somebody's angry in there.
That's correct.
That's all I can see.
Collect displays. Yeah, I can't see I can't see where the mouse is though. Which side of the screen is that off on? Nope. Oh, fuck. There's no function keys. Oh.
Is it going to take longer than the first one for Linux laptop?
I can't see to grab it. I can't see where the window controls are. Is it going to do the exact same thing again? It's gonna steal my display again.
Yay!
Not yay yet.
What do you mean? It looks good to me. Let's go. Ship it. Ship his machine.
If you stand over there, I can control it.
Yeah.
You can look at the thing.
Yeah, I got it. 1 second.
Wait, we lost him again.
No, we're in a good place. All right. Not the worst place, but this is what you're getting. The tiny screen. Excellent. Through the shit like Bane, I guess. Some assembly required. Lessons from. Oh, you gave me the full time. Thank you so much. Lessons from Lego, Connects, and Mario Kart. I promised a rant, which is a decently articulated but not terribly well organized spurt of verbal anger. Like all of our dads, I'm not angry, just disappointed. Maybe I'm a little angry. Anyway, any Lego fans out there? I certainly am. I love building sets. I love building them by myself. I love building them with my kids. A while back, I came across this set, and I built it with my daughter. And you're going to say, wait, that's not Lego. And you are right. By 2011, Lego's toy brick patent had expired, and other companies were free to make building block toys. This one is from K''Nex. It is called the Lego and Standard Cart Building Set. The first lesson, be careful naming things. They might ship your placeholder text. Hemingway would love this. You can cut 66% of the words. Anyway, Mario Kart. It was a very frustrating experience. We opened the wedge-shaped box. We poured the pieces out. We unfolded the instructions. And they were this. Mario's cart should come together in 7 steps. If that feels like too few, that's because it is. Diffing between step to step is very confusing. There's a color change to indicate new parts. While going wherever, arrows are going wherever, and they lead us to building and unbuilding and correcting, and it's not the cathartic father-daughter experience. There's like repressed anger that's have to happen. Also weird, once it's built, you have to chop Mario in half because his legs don't fit in the cart, all Darth Maul style. You mount the torso on the adapter, and then he drives the cart. We've donated the legs to the metaverse, which gravely needs them. So the box calls attention to its pullback motor. What it says is, play with me. My box is a wedge. Take me off some sweet jumps. And that results in this. My son picked it up, and he did exactly what it wanted it to do. And he played with it. Once assembled, this toy did not withstand the play that it had requested. I did keep it, thinking it'd be a good, bad example. And so if that's bad, what's good? It's very useful to contrast a good example against a bad one. Who does this well? You already know. We're talking about Lego. So this is the Audi Sport Quattro. It lives on my desk when my son isn't playing with it. Even when he's rough with it, it comes back very usable. But it's not just structurally sound. Let's have a look at the supporting physical and digital assets that make this a joy to play with. Over here, this is a bill of materials. I can see everything that's supposed to be there. If I have what I need before I start, I'm all set. I notice pieces that are there that aren't supposed to be. If they've shipped extra ones, you can throw those out, probably a security issue. Even more bill of materials, this is what I need. What do the steps look like? Excellent. The requisite parts for every step are detailed. For piece scale, you can measure the piece against the page to make sure that you've got the right one. If you're counting the studs, they're not hidden. And it's not just about what's in the box. The Audi Sport Quattro is a retired product. That's what the tiny red text says over there. Lego keeps the instructions on the site anyway, even though they don't sell it anymore. There's a reason the earlier Connects instructions were photos. That's because they don't exist on the internet. They're not selling it. It doesn't make them any money. They just throw it away. Don't do that. So one of these vehicles lives in shame, and the other one is continually upgraded. My son thought this one could use some fire, some pewers. It's wonderful now. So building these 2 vehicles reminded me a lot of working with many of the projects and products that I've encountered, some made by the very people in this room. My work often requires quickly familiarizing myself with these and other digital toys. What I'd like to ask you to do while thinking of Lego is to think of the missing steps. Don't just leave breadcrumbs for yourself. or future versions of yourself or people from your project, think of new users. Version those docs. The old stuff is still running out there. Make it extensible by others. Your kids want to play with it, your friends want to play with it, let them add things to it. This talk was just as much for me as it is for you. We don't need to be taught as much as we need to be reminded. Did you feel extremely seen or possibly even personally attacked? Let's do better together. It's not enough to make the parts fit together. You have to empower others to play. I'm Jeremy Tanner, Penguin on the Twitter, for however long that lasts. Find me to talk Lego, infrastructure Lego, rally cars, patent law, or pizza.
Thank you. What am I taking?
You're taking the mic. Oh, this one is me.
Do you need a mic stand?
No, I'm good, I guess.
Okay. Okay, let's see if yours works.
So we had the fun ones. It's time for the boring one. I will be talking about end-to-end testing of Kubernetes controllers and the patterns and anti-patterns that we learned at Ilotl during the last year. You may ask yourself, what's the Kubernetes controller? My really wide definition is that there is a cluster somewhere, there is an app running in cluster, we call it controller, and it listens to the changes in the cluster state. And when the change happens, it basically tries to respond to that change by either modifying objects which were changed or adding in new ones or however you like it. So the question is how to test it end to end. Obviously, you will need a cluster. You will need to deploy your controller. And usually, the way that the good end-to-end tests are born, the first step is manual testing. So you'll get a cluster. You'll get the kubectl. You'll probably try to apply some change in the cluster with kubectl. You will wait for your controller to respond to that change, and you will try to do some kind of assertion. Also using kubectl, probably getting objects in the JSON format, maybe some kind of parsing or whatever. And then you take first step on automation. So it's kind of like, it feels almost natural to put the shell scripts because you are testing with kubectl, so why not put those kubectl commands in the shell script? And I'm here to tell you that it's not the good way. So with shell scripts as tests, it's hard to run them in parallel. It's hard to run the single test. It's hard to control how the errors are thrown. Yeah, we had that as well. So it's quite common that if you don't clean up the state after your test, it will just mess another test in your test suite. So the lesson that we learned is that it's not a good tool for a job, and we learned it a hard way because we found ourselves kind of like implementing utils we already had in controller code, but also writing like a mini framework to run the shell scripts from test directory. And you can get all of that out of the box with any language that has Kubernetes client and good testing tooling. So what we did, we just rewrote everything in Go because we had our controllers implemented in Go. So right now it's easy to run them locally. It's easy to run them in parallel. It's also easy to run like single test. The test command is also separated from the way we set up the test environment. So you can actually set up the test environment once and then just rerun those tests. And there is a lot of goodies that you get out of the box. You get basically like the weight utils, which are super useful for tests. So I'm not saying that shell scripts should go away for end-to-end testing of Kubernetes controllers, because we still use them, but we use them only to set up the test environment. So the way it looks right now, we've got simply those 3 tests. In the first one, we set up the cluster and build the image, copy the image to the cluster, and the run test script is actually very thin wrapper around go test where we passed kubeconfigs. Yeah, I think that's it. Thanks for your attention.
Who's next? Next up, logging in 5 minutes with Sanjay. Yes. Somebody have an adapter? Yes.
Okay. Hey everyone. My name is Sanjay. I'm coming over from SUSE Rancher, working on a project named Opney. I'm going to start this lightning talk by clicking a button, this button. I've clicked it, and and so what this button does is it's it starts shipping logs over from this cluster to my upstream Opney instance. Opney is a open source multi-cluster observability and AI ops tool. And let me go to this slide. Okay. I shouldn't have done that. Okay. So the problem is I want a centralized logging sink that I can send logs to from multiple clusters and a UI to explore these logs. The solution here is Opney. So what I've done already is install Opney into a Kubernetes cluster. I've enabled the Opney logging backend. And for every cluster you want to ship logs from, you install the Opney agent. So I've done all that before this demo. And what I've done by clicking that button is I enabled the logging capability for the cluster in the Opney admin UI. And so now that I've done that, I should be able to navigate over to the Opney logging dashboard to explore these logs that I've started shipping over to the upstream cluster. So I will do that now. So this is what the cluster, oh, you guys can't see yet. So this is what the dashboards look like before I start shipping over. And let me just do a quick sanity check that it is shipping. Looks like it is. I'm going to hit refresh.
Well, that's 2 buttons now.
2 buttons. But yeah, now logs have started shipping over. I have deployed a sample application to a downstream cluster, the Google microservices boutique application. So there should be a ton of logs that are coming in. I'm almost out of time, but if I want AI insights, I would navigate it over to the Opney dashboard. You would let this run for an hour, and this will start populating with AI insights.
Setting up logging. Good. Next up we have demystifying with Ben. Yeah, good.
Keep your fingers on keyboard or?
I think I will able to hold it.
Okay.
Great job on that clock.
So guys, before you even start, you put the stopper on me 5 minutes, okay? I tell that I changed the talk in the last day. Hope you forgive me. Do you see anything? Searching. Good for him. So, while it is searching. Awesome. Okay, so
And go. Okay, so we are going to talk about Kubernetes vulnerability scanning. Okay, we are scanning images in Kubernetes, and because we are taught to do so, and most of the security engineers, you know, feeling this way. Okay, they're getting overwhelmed with the results. Okay, we are getting for, you know, the latest Elasticsearch, okay, image, official image, you will get like more than 50 or not around 100 vulnerabilities. So, okay, the question is whether in Kubernetes, whether we can leverage Kubernetes to make it, this whole thing more efficient, okay? And I will tell you why it is more efficient. So how vulnerability scanning is working, okay? Actually, there is the scanner who creates an SBOM using the container image. It lists all the packages, then goes to all the publicly available vulnerability databases, cross-checks, okay, the packages for vulnerabilities, and creates this overwhelming list, okay? Now, it's bad, okay? It's bad because it's very, very hard to maintain, very, very hard to decide, okay, which vulnerabilities are really vulnerable and can be exploited inside the container, because there are a lot of packages which are not in use inside the container and not running, therefore they are not exploitable. There are other kinds of vulnerabilities which cannot be exploited because they are, the program flow doesn't touches them. And there are other questions, okay, that these lists doesn't have obviously 0 days, are not listed here. Usually our own code is not listed here, so there are a lot of problems here. And now the question is, okay, what can we do, okay? So bro, we are using eBPF, okay? What do we do? The containers are running inside Kubernetes, okay? We are enabling eBPF and streaming data from eBPF to see the system calls of exec and open, okay? These two system calls enable us to see which program files are loaded into the memory, okay? Crossing them together with the SBOM, right? The SBOM lists you all the packages you have inside the container, okay? And not just the package names, but also which files are making them. So if we're crossing these two information of which files in use inside the container together with the full SBOM, it turns out we can create a filtered SBOM. It says that it causes us to create a shorter one, and if we feed it to the vulnerability scanner, as it turns out, okay, we'll get much less image vulnerabilities. So therefore, in the KubeScape project, we have released yesterday a POC, okay, which you can run for yourself, which actually built upon the Falco-based libraries, and actually, as a daemon set, okay, looks into all the pods which are starting, all the containers, which files they are touching. It records all those events, then creates the SBOM, filters the SBOM, and creates a vulnerability results, okay, based on that, and post it to the cluster, to the API server as custom resources. And it turns out, okay, and this is hot from the oven, okay, this is a scan summary of NGNX image. You can see that it has a few vulnerabilities, if I'm scanning it simply, okay? I have nearly 400 vulnerabilities, and it turns out that I've detected that only 4 of them are in the memory. Now, obviously I'm cheating here, okay guys, I'm telling you, but because this NGINX is not really running in the sense that it is not configured to do TLS and stuff like that. But even if you think about, okay, that I'm loading libSSL and all these modules of NGINX, it will turn out to be a much smaller number than this 400. So it is awesome, okay, because it can create, it can return the force to the right place, okay, and we as sometimes security engineers can be less overwhelmed with all these vulnerabilities simply by using some eBPF magic and Kubernetes to automate. So this is in the KubeScape project, okay, this is a new Git repo. You're welcome to scan, follow it, okay, we'll release every week a new update, okay, and we'll be really, really happy to get feedback on how you would like to use this feature. And yeah, wait a second. I have 10 seconds.
Okay. Hi, everybody. My name is Mariana. I work at Amazon, manage the services for Prometheus. We launched our service last year, and over this time, as we scale our service, the deployments start to take too long, slowing down the release of new features and bug fixes. So today I'm going to talk about the internals of our service and how we speed up deployments without impacting availability. Our service uses Cortex, which provides a long-term storage solution for Prometheus metrics. Cortex is designed as a set of microservices, and in on large installations, a common problem are the long deployments caused by my favorite component, the ingesters. Ingesters receive time series samples from distributors, keep those in memory, and every 2 hours, write them into a long-term storage solution, such as Amazon S3. When an ingester shuts down because of a rolling update, for example, the in-memory sample can be discarded to avoid losing data. So given that, Cortex uses a write-ahead log to write all incoming series samples to a persistent disk until they are flushed to the long-term storage. And when the ingesters restart, the wall is replayed to recover the in-memory state, which takes time. So to improve deployments, we needed to find a way to update multiple ingesters at the same time. And the ingesters are deployed using a stateful set, which now allows multiple pods to be updated at the same time through the new max unavailable feature that was recently launched on the 24 release of Kubernetes. However, this didn't work for us because of how we replicate ingesters for high availability purpose. So at AWS, we replicate services across multiple AZs to reduce blast radius and ensure continued operation, even if an AZ becomes impaired. And on Cortex, we do that by using a feature called zone-aware replication and topology constraints to hold multiple replicas of each series in distinct AZs. Besides that, to make sure that we always have data replicated between different AZs, we need a quorum of 2 out of 3 ingesters up at any time. This means that during deployment, we need to guarantee that we are never updating together 2 or more ingesters that are handling a given time series. So the only way we can update multiple ingesters to improve the deployment times is by updating pods that are in the same AZ only. And this type of control is not possible today using the max unavailable feature launched with recently. So to do that, we created our own custom controller for zone-aware updates that can be used by any high available quorum-based application, not just Cortex. At each control loop, the controller watches for stateful set and pod events to create a map of the pods in each AZ, checking if there are pods that are in the old revision that need to be updated. And the ZAU controller also allows users to specify the name of Amazon CloudWatch alarm that you pause the rollout in case, for example, to prevent deployment from proceeding in case of canary or test failures. So the controller never updates pods from different zones at the same time, and during deployment, it exponentially increases the number of pods deleted, deploying slowly at first and accelerating as we gain confidence in the new revision. And the number of pods deleted never exceeds configurable max unavailable value. We also created an admission webhook controller that extends the pod disruption batch concept to allow multiple disruptions only if pods being disrupted are in the same zone. I will not enter in details here because of the time, but the reason why we created this ZDB controller was to allow us to safely upgrade multiple nodes at the same time to speed up, for example, the rollout of new OS security patches. Here are some results. We started to use the new controllers in July and August, and since then we have improved substantially our deployment times. to finish, I added the link here to our GitHub repository. We open source the controllers last month, and we would love to get feedback from the community. So if you are running Cortex or have a similar high available quorum-based application, give them a try and let us know. And that's all. Thank you.
No, I'm good. As long as it shows up. Yeah, unlike George, I'm running a Mac, so. All right. Hello, everyone. Welcome to the Shifting Sands of Security and Compliance in the Cloud. I am Sunny Shi. Work at Stacklet. Previously was at Hulu and Capital One. Have some hobbies, have some social media. Anyway, let's get into it. So, what is good about the cloud? Number one, you get to go fast, right? So you get to go like Sonic. These benefits mean that you get a lot of VC money if you add cloud to your tech or to your product, which is very good. It's also web scale, of course. You get to use Amazon servers instead of your own. But also you don't have to, because there's this thing called serverless, and it's also pretty cool. I heard you also get money for that. And then developers, they can do stuff quickly, and you don't have to wait for those annoying server provisioning people, you know. So you also get to go to cool parties and cool conferences like this one, which I think is a great perk. There are some downsides, though, and that would include breaking things. The first of which is companies get hacked. On top of that, something like a misconfigured S3 bucket can lead to data loss. I'm just noticing the timer is not on. So I think I have infinite time. Costs can start to go through the roof. And then engineers in charge of your cloud at your company, they start looking like sad Keanu. This is an interesting statistic from Gartner. Through 2025, 99% of cloud security failures will be the customer's fault, which means it's your fault, not the cloud. And that's what your CISO will look like, sad Affleck. But of course, we're engineers, and I'm gonna have some code here, so feel free to take pictures and stuff of this, because it's gonna be super useful. Let's start by writing some Python. So we want to go check those buckets, right? So let's start importing Boto 3. We'll write this check actions function. But then we realize, oh, we actually need some more code for that, because we also got to iterate over all the buckets. And then after we iterate over all the buckets, let's just print that out to the console, because that would be super useful. But then we realized we actually want to do like messaging, so Slack. But then someone said they actually want it in the form of an email, so we can write that code too. And then that's all good, but then what about unit tests, right? So let's also just write like 3,000 lines of unit tests for this. And that should be great. But now we got to do that for all these other AWS resources here. So we'll be employed for a long time. And we also get to do it for all these other cloud providers and PaaSes and whatever. So clearly there's a problem here, because I'm just running this on my MacBook here. And when I was making the slides, I actually got this message. It said I was writing too much code. And then my browser died. So I can't do it for all these other providers and all those other resources, because my computer's going to die. Here's where we get into Cloud Custodian. So we write rules and policies in an easy to understand YAML DSL. And we construct policies from a vocabulary of filters and actions. So all that stuff that we had to write before, that's all one line of YAML, 2 lines of YAML. It's open source, and it commoditizes governance, which means that you as an engineer, you don't care about governance, but somebody at your company probably really does, and so they get to write the policies instead. You get to write policies for one resource and carry that knowledge forward to all these other resources and cloud providers that are supported. And on top of that, it's serverless, it's event-driven. We have auto remediation, security, compliance, cost savings, tagging, all of these different domains. Cloud Custodian can help you target these problems. And of course, it's production grade, hundreds of users in all sorts of environments, so big companies, small companies, huge banks, media companies, et cetera. They all use Custodian. If we take a look at this policy here, First, we select a resource type. In this case, we're talking about S3. We define the filters that we care about. So this is a cross-account filter that's basically saying we want to whitelist access to any bucket from that account ID. And then finally, the action section, which is a little bit long, but it's basically saying send this notification out via Slack to the resource owner, and also send it via email. So one command, write the file, run it, you're good. So next time you need to enforce a rule in your cloud, come check out Cloud Custodian. You can pip install C7N or Docker pull it. We're also on Slack and Gitter. And then also we're over at KubeCon. So come over by the expo hall. We're at ContribFest, and we also have an introduction to Cloud Custodian. Both of those sessions are on Friday, so come check us out. And I'm right on time. So thank you, everyone.
To be honest. So I want to thank Sarah Novotny for helping us out today until it was time for her to take off. I want to thank especially Lexi, who didn't get a chance to come in. So if we're still streaming and Lexi is not horizontal and can see the screen, then I want to just thank Lexi for all of her hard work. Okay. And for all the staff, the audio people, everybody else, but in reality, it's all the people that put this in. This isn't a money-making deal, and the greatest thing about it is that everybody's here because they want to be, and they want to share all the stuff. So thank you, all of you for coming, and let's have another one of these as soon as we absolutely can. Have a great week. I want to thank everybody at Kinvolk, and wherever they may be employed now, for having done this for so long. And let's all go have a great evening, have a great time at KubeCon, do all the other things on Monday and Tuesday. Have I forgotten anything? It's time to go party. Thanks.